Good afternoon, everyone. I, Dr. Ripon Kohli, welcome you all on this last day of 6-day online ATAL FDP on advancing smart manufacturing, unlocking the power
Ma'am,
of
please.
4.0. Today in this session, we have Dr. Sheetal Soda, who is an accomplished academician and researcher with over 15 years of experience. She holds a PhD in green supply chain management. I welcome you, ma'am. Currently, she is serving as an assistant professor at NIT Jalandhar in Department of Industrial and Production Engineering. Ma'am, I hope your today's session will be an enlightenment session and experience for all the participants. Over to you, ma'am.
Yeah, good morning, ma'am, and thank you again for the nice introduction. And I'm also very hopeful that I will able to share my knowledge to my participant on the green manufacturing. So should I start, ma'am?
Yes, ma'am. You may start your session.
Okay, thank you. I will share my presentation. Yeah, ma'am, screen is visible?
Yes, ma'am. Screen is visible, ma'am.
Okay, thank you. Good afternoon, everyone. Welcome to today's sessions, which is on sustainability in smart manufacturing, green technologies, and energy efficiency. I am Dr. Sheetal Soda, and I am an assistant professor in the Department of Industrial and Production Engineering at Dr. B.R Ambedkar National Institute of Technology, Jalandhar. Participants, this presentation, as you know, is a part of your short-term course which you are attending, AICTE ATAL sponsored 6 days online faculty development program, which is on advancing smart manufacturing, unlocking the power of Industry 4.0 for modern applications. Today, during this particular session on sustainability in smart manufacturing, we will explore how green technologies and energy efficiency can transform manufacturing into a more sustainable and environmentally friendly processes. So today's presentation is mainly focused on the sustainability, and that's in smart manufacturing. So here's an overview of today's session. We'll begin with an introduction to sustainable manufacturing, its definition, and its relevance in today's scenario. Then we will examine the environmental challenges which are posed by traditional manufacturing methods before transitioning into the sustainable solutions. We will also discuss the enablers such as green technologies, energy efficiency, and we'll explore the challenges in implementing these practices, the role of government policies and regulations, and we will conclude with the insight into future trends. Participants, please feel free to note down questions as we move along. I'll address them at the end of the session. So to begin with, participants, we should first try to understand that what is sustainability. And sustainability in smart manufacturing is a concept that combines environmental consciousness with economic and social goals. Here are three things which we are basically considering in sustainability. That is the environmental consciousness with economic and social goals. So the pursuit of sustainable manufacturing is very critical in nature, which drives the adoption of environmental conscious practices and technologies. So in this particular session, we are going to explore the importance of sustainability, how we can delve into the current trends as far as sustainability is concerned, and we will showcase the practical strategies which help us to optimize the manufacturing processes for environmental impact. This will also examine the role of energy efficiency, renewable energy sources, circular economy principles, and innovative smart technologies. So if we want to understand the sustainability, we should focus on three parameters. That is the environmental consciousness, economic aspect, and the social goals also. So according to UN Brundtland Commission, we can define the sustainability as the sustainable development is the development that meets the need of the present without compromising the ability of future generations to meet their own needs. When we are talking about the three aspects, which includes environmental, social, and economic, then we can say this term as the triple bottom line. Means this concept suggests that in addition to economic performance, which is the main goal of any industry, a company must account for so that we can say that the particular company or industry is at least sustainable. So another common way of saying or integrating these three parameters, that is the environmental, social, and economic, is that people, planet, and profit. So sustainability is the intersection of these three concepts, either in terms of environment, where we are focusing on our planet, or economic, where we are focusing on increasing the profit of our organization, and the social, which includes the people of the society. What should be the benefit to the society while doing or approaching towards the sustainability? So sustainability triple bottom line includes these three main parameters: environmental, social, and economic. Here in today's session, I'm focusing on the sustainable smart manufacturing. So what does sustainable manufacturing mean in practice? Sustainable manufacturing focuses on reducing waste, reducing emissions, minimizing resource use while ensuring profitability and fairness. So this particular slides help us to understand the entire supply chain of a manufacturing process and how we can implement certain sustainable practices to each and every stage of the manufacturing. Starting from the very first stage, that is the raw material extraction, we can use renewable materials that don't deplete the natural environment. So this is the first step. Then we can use fewer materials. The amount can be reduced, and inputs and materials which are non-hazardous or that can be recycled, we can use that. Then during the manufacturing, modifying the technologies or the production processes which uses less energy or water or material means we have to reduce the amount of the energy or the resources we are using so that we can produce less waste. Then once the product get manufactured, if we consider the packaging and the transportation, then using less packaging, lowering product weight, using more efficient transports and logistics is another practice which we can implement to make it sustainable. Then as far as design is concerned, designing the product so that it should be reusable, remanufacturable, recyclable, or biodegradable. And expanding the life of the product, making it easier to repair or design it to use fewer resources during the use. And at the same time, working with the stakeholders like the customers, retailers to reduce the environmental impact of sales and distribution. So starting from the raw material extraction to the final usage by the customer, we can implement number of sustainable practices in each and every phase of the manufacturing. And specifically here, we are going to focus on the smart manufacturing. But before considering the other parameters for the sustainable smart manufacturing, let's look back to the traditional manufacturing. Traditional manufacturing methods have left a significant environmental footprint. The environmental impact of traditional manufacturing, either in terms of energy consumption or in terms of waste generation or water and air pollution. So if we start with the first, that is the energy consumption in traditional manufacturing, which heavily relies on fossil fuels, which leads to high energy consumptions and greenhouse gas emissions. Another thing, another impact of traditional manufacturing on environment is the waste generation. Inefficiency in the processes which results in the waste of raw materials or byproducts and packaging materials. And lastly, the industrial processes often releases pollutants into air, water, soil, which harms or disrupts our ecosystem and pose healthy risk to nearby communities. Another impact is the energy consumption in manufacturing. Like I have just told you that manufacturing processes often rely on fossil fuels. So fossil fuel is the main energy consumption parameter, which release greenhouse gases into the atmosphere. Then if we want to compare the processes used in the manufacturing, like smelting, refining, and chemical production, which requires a significant amount of energy as inputs, which contribute to high energy consumption. So our aim is to reduce the energy consumption to make it more sustainable. Then there are certain efficiency gaps, like manufacturing facilities operate with low energy efficiency. If the energy efficiency is low, then energy consumption will be more, which lead to the wastage. So wasted energy and it increased the environmental impact. So this is the another form of impact of energy consumption to our environment. Now, if we see the reason behind these impact of traditional manufacturing on the environment, then the major cause is the rise of mass production. The emergence of mass production, which revolutionized the way goods were manufactured and consumed, transforming society and shaping our world. Rise of mass production. Due to the rise of mass production, the output increases. It decreases the cost. And while increasing the output and reducing the cost, there are environmental strain also. Why there is an increase in the output? Because due to mass production, which enabled the creation of goods at unprecedented scales. meeting the demands of a growing global population. And because the production is in mass, we are manufacturing in a mass production, the cost get reduced. The economies of scale, which is associated with mass production, led to lower production cost, making goods more affordable for consumers. So we are producing more number of products at less amount, which ultimately simultaneously affecting our environment. So while mass production brought benefit, it also contributed to increased resource extraction, pollution, and waste generation. So industrial revolution so many benefits, but environmental strain is also attached with this rise of production in terms of increase in the resource extraction, pollution, and waste generation. Another thing is the innovation in manufacturing technology. These are the things which increases the impact of traditional manufacturing on our environment. So innovation in manufacturing technology, which includes interchangeable parts. So this innovation of interchangeable parts technology allowed for standardized components, which simplify the assembly and reduce the production cost. Similarly, division of labor by using the specialized worker for a specific task. This also increases the efficiency. Third is the power-driven machinery. Steam engines and water wheels. We are comparing the first industrial revolution with the second industrial revolution. How the traditional concept of manufacturing changes during different industrial revolution and how it increases the production and the efficiency and reduces the cost, but along with the environmental strain. So power-driven machinery, we switch over to steam engines and water wheels, which are powered large-scale production, which replaces the manual labor. So by the different means of innovation in manufacturing, again, we have increased the production and usage of the resources. Another example of increasing the production is the which increases the efficiency and the output. So Henry Ford models which innovate assembly line, this revolutionized the car manufacturing, which increases the number of products manufactured during a particular period of time. So the assembly line enabled the efficient production of large quantities of identical products, which reduces the cost also. So mass production led to reduced cost and made products more affordable for a wider market. So the first important parameter of the impact on traditional manufacturing on environment is the rise of mass production. And second is the deforestation and land use. So how this impact our environment? In any manufacturing process, the first step is to extract the raw material extraction. So manufacturing requires vast quantity of raw materials, either in terms of timber, mineral, fossil fuels, which are often extracted from forest and our natural ecosystems. So due to this raw material extraction, there is a habitat loss also. Deforestation for industrial developments destroys the habitats, because here we are displacing the wildlife and threatening the biodiversity. Another important effect is the soil degradation. Land clearing and mining practices can lead to the soil erosion or nutrient depletion and desertifications, which ultimately leads to the climate change. So deforestation contributes to climate change by reducing the Earth's capacity to absorb carbon dioxide. So deforestation and land use become another important parameter which affects the environment. Third important parameter is the impact on biodiversity and ecosystem. Here we can talk about the pollution. Industrial pollutants contaminate water, soil, and air, which harms wildlife and disrupts our ecosystem. Then habitat destruction, we have just discussed that industrial development and resources extractions destroy habitat, which leads to a species extinction and loss of biodiversity, and ultimately the climate change. The greenhouse gas emissions from manufacturing contribute to climate change, which is altering ecosystems and causing widespread environmental change. So, because of these number of reasons which we have discussed, which are impacting our environment, there is a need to implement or start with this sustainability practice. So now we will see how the rise of sustainability in manufacturing take place. Manufacturing has a massive environment impact. But companies are under increasing pressure to adopt sustainable practices. So this pressure which is faced by the companies to adopt sustainable practices includes three important things, which are environmental responsibility, economic viability, and social equity. Firstly, environmental responsibility means this environmental responsibility says that we should reduce emissions. This is our environmental responsibility, that we should, whenever we are doing any project or anything, then we should focus on reducing emissions, reducing waste, reduce resource consumption, so that we can combat to climate change. Secondly, sustainability is economic viable. Initiatives like energy efficiency, waste reduction can significantly lower the operating cost and increases the profitability as well. So we should have to see this aspect also. And lastly, because there is a growing, we can say, emphasis on social equity, we should ensure that the manufacturing practices we are adopting should align with ethics or the ethical principles. Ethical principle, we can say, which include fair labor, responsible resources use, so that it will benefit society at large. So why there is a need for sustainable manufacturing? Climate change, resource depletion, and pollution, which we have just discussed in our previous slides, that are the impact on the environment of traditional manufacturing, are major concern. And sustainable manufacturing is critical to address these issues, either in terms of environmental impact or economic advantage or social responsibilities. So manufacturing process, which are often generate significant amount of waste and emission, which contribute to climate change and environmental degradation. So if we adopt sustainable practices, this will help in minimizing the environmental impact. So this is one of the most important need for sustainable manufacturing. Then sustainable initiative can lead to cost saving. It reduces the cost through energy efficiency, waste reduction, and optimizing the resource utilization, which enhances the profitability and competitiveness. So economic advantage is also attached with this. So this is the another important thing which helps or comes under the need for sustainable manufacturing. Then sustainable practices should align with the ethical business principle, which fosters a positive social impact by protecting the environment and ensuring responsible resource management. So we can say sustainable manufacturing is not just about environmental responsibility, but also about business benefits. Sustainable manufacturing can lead to cost savings, improved efficiency, and enhanced brand image. Okay, so uh, don't get confused that when we are talking about the sustainable word or sustainable manufacturing, then we have to focus on only on our environmental responsibility. There are a number of other things which are attached with this. So to start with, we can start with implementing by using the sustainable materials and processes. Sustainable materials like renewable resources we can use using materials from sustainable sources like bamboo or any recycled material. Then bio-based material can be used. We can develop materials from renewable sources like plant-based polymers. And then the another important thing is the closed loop manufacturing. Designing the process, closed loop manufacturing or circular economy, which we are going to discuss in detail in our later slides. Closed loop manufacturing means designing the processes that minimizes waste and maximize reuse. This is circular economy. Another thing we can do is the sustainable material selection and life cycle management. Material selection, while doing the material selection for the manufacturing, we can go for the sustainable material by prioritizing the environmental friendly materials, which have low environmental impact and high recyclability and responsible sourcing. Similarly, during the life cycle assessment, we can evaluate the environmental footprint of products and processes from raw material extraction to disposable, while identifying the other areas for the improvement. Similarly, as far as designs are concerned, we can go for the eco-design principle, which means that we can design the products with sustainability in our mind. By keeping in mind that how we can reduce the material usage, how we can reduce the energy consumption, how we can promote the reusability of the material. Waste reduction and recycling initiatives are one of the important area which help us to become more sustainable. Either in terms of material recycling, means we can choose a material which can be recycled to create new product. We can reduce the, we can minimize the waste. We can design the process in such a manner that there is a less generation of waste. The product or the component we are using should be such that reusing of those components and material to extend product life cycle. So these are the certain initiatives that can be taken as far as waste reduction and recycling initiatives are concerned. Then as we just talk about that the circular economy principle in manufacturing. See participants, green manufacturing, when we talk about the green manufacturing or sustainable manufacturing, then it refers to the adoption of eco-friendly and sustainable practices throughout the entire manufacturing process. As I described in very first slide, which consists of the entire supply chain of a manufacturing process, that we have to implement the measures for sustainability in each and every step. Green manufacturing, the main aim of green manufacturing is to strike a balance between environmental responsibility and economic growth. From raw material extraction to production, distribution, or disposal, green manufacturing tries to minimize any negative impact on the environment. So this circular economy principle is one of the important principles which helps us to achieve this. How? Earlier we used to talk about the linear economy or the linear manufacturing. Here we are talking about the circular economy. Circular economy means we have to see how first step is to eliminate the waste by designing for, means at the very first step of designing the material, we have to take care that the material we are using for designing a particular product should be such that it can be reused, repair, and again recycle, so that we can follow a circle. Maintaining the value of products and material throughout their life cycle. And then regenerating natural systems by using renewable resources and reducing pollution. So here in circular economy principle, our main aim to make the entire supply chain sustainable. While talking about the supply chain management, we are talking starting from the raw material or the input of the process to the final product when it reaches to the customer. So while making our supply chain sustainable, we should also take care of the supplier audits. Supplier audit, which includes that we should assess the suppliers. We should work or tie up with those suppliers which also thinks in the same manner as far as environmental and social practices are concerned. Then green procurement, sourcing sustainable materials and products from responsible suppliers. Means the entire supply chain, not only you as a one person, but your entire team will think and do the same practices. So sourcing sustainable materials and products from responsible suppliers. That's the part of a green procurement. Then the communication should be transparent between the two parties, that the sharing information about sustainable practices with the stakeholders. You should be very clear with your stakeholders about the sustainable practices you want to implement in your industry. So there are a number of case studies which gives us the success stories of green manufacturing. An automotive company which successfully implemented energy efficiency measure and reduces its energy consumption by 15%. Similarly, there is a tech company which adopted innovative recycling initiatives and achieved a remarkable 95% increase in the recycling rate. Then another, as far as cost saving is concerned, a manufacturing company saved $5 million annually by operating costs through waste reduction and recycling initiatives. So these examples highlight the potential for cost saving, efficiency improvement, and environmental benefits. So now we will see some of the green technologies which we can use for sustainable manufacturing. Green technologies are very much essential for creating a sustainable future. By adopting these technologies and practices, manufacturers can contribute to environmental protection, help in reducing cost, and improve their competitive advantage. We can say, participants, that green technologies are a cornerstone of sustainable manufacturing. By focusing on renewable energies like sources like solar panels, wind turbines, or geothermal systems, which reduce the our reliance on fossil fuels. Then this green technology, which focus on circular economy, which involves circular economy, which we just talked about, that which involves designing the processes and products that minimize waste and promote the use of either reuse of materials by creating a closed loop system. So the main focus of circular economy principle is that we should minimize the waste and maximize the resource utilization. Then we can also focus on the water conservation technologies such as wastewater recycling, rainwater harvesting, which plays an important or a critical role in reducing water consumption and protecting this vital resource. So as far as renewable energy are concerned, we can talk about the solar power, where we can install photovoltaic panels to convert sunlight into electricity by reducing reliance on fossil fuels. We can switch over to the wind power by utilizing wind turbines to generate electricity from wind energy, particularly in the areas where with the consistent wind patterns. We can switch to the hydropower, which harness the power of moving water to generate electricity, which is suitable for location with rivers or waterfalls. We can also switch to the geothermal energy, which taps into the Earth's internal heat, offering a reliable and low emission resources. Then as far as reducing the waste and the recycling strategy, we can go for the waste minimization. We can implement the lean manufacturing, which focus on reducing or minimizing the waste. So principles of lean manufacturing can be implemented in our in industry to minimize waste generation. We can use the process of recycling, reusing and repurposing material, which minimize the landfill waste and conserving resources. We can go for composting, which means that converting organic waste into nutrient-rich compost for soil enhancement. And as far as water conservation and management parameter is concerned, water efficient equipment can be used, utilizing technologies like low flow fixtures and high efficiency washing system, in which we can reduce the usage of the water. We can go for the water recycling by treating and reusing wastewater for non-potable purposes and conserving water resources. We can also go for the rainwater harvesting by collecting and storing rainwater for irrigation and other non-potable uses. So by ensuring the whole supply chain is eco-friendly, it is not that easy. Businesses must ensure that their suppliers, transporters, and any other parties which are involved should share a similar commitment towards sustainability. Then only we can say that our entire supply chain is green or sustainable in nature. So when we are saying the term green supply chain, we are not adding just a word green to supply chain, or we are not adding the word environmental consciousness or sustainability to our traditional supply chain. We actually means that all the stages or all the entire supply chain should focus on this sustainability. Either in terms of sustainable sourcing, means partnering with suppliers who prioritized environmental responsibilities and ethical practices, or either go for eco-friendly packaging using sustainable packaging materials and minimizing packaging waste, transportation optimizing, optimizing routes and logistics to reduce fuel consumptions and emissions. The thing is that during the entire process of manufacturing, we should practice in such a manner that we are doing something towards the sustainability. We can talk about the green product design and the life cycle management, where we are considering the environmental impact at all stages of product development, starting from the designing to the final, from material selection to the end life of the disposal. We should design for durability, repairability, and recyclability so that we can extend the life of a product by minimizing the waste generation. We can implement eco-friendly packaging solution by using recycled material, and we can minimize the packaging time also. Now, after green technology, participants, we will see how energy efficiency plays important role, and especially in smart manufacturing process. So energy efficiency is not just an environmental goal, but here we are talking, or we are concerned with the business imperative also. Smart monitoring system, if we say, which allows manufacturers to track energy consumption in real time and make data-driven adjustments. Or we can say by replacing old or inefficient machineries with modern equipment, which are high efficiency motors. This also reduces the energy cost. Ultimate aim of energy efficiency in smart manufacturing process is the optimizing the manufacturing process by eliminating any waste or any bottleneck, so that we can ensure that energy is used efficiently at each and every step. So energy efficiency is crucial for sustainable future of smart manufacturing. We have participants already. I think you have attended a number of sessions on smart manufacturing. So when we are talking of the smart manufacturing, it leverages the digital technologies, either like IoT, IIoT, AI, cloud computing, which ultimately enhance the efficiency and productivity. In smart manufacturing, our focus is on the data-driven decision making. We are using a real-time data analytics and insight drives, which inform decisions to optimize production and improve efficiency. Then in smart manufacturing, we are talking about the automation and robotics, automated systems and robots, which enhance productivities, which reduce human errors. And all these things are interconnected when we are talking about the smart manufacturing. We have integrated system and platforms which enable seamless communication and collaboration across the entire manufacturing cycle. So there are a number of drivers for the energy efficiency, especially if we talk about the sustainability goals. In sustainability goals, these smart manufacturing help us in reducing the carbon footprints, and which reduces the environmental impact. It also helps in reducing the cost and increasing the profit. It also helps us in meeting the energy regulation standard, which is according to the regulatory compliance. So in smart manufacturing, we are focusing on optimizing energy consumption in production processes. How we can optimize? Because this is one of the important objective of smart manufacturing when we are making our smart manufacturing sustainable, that it should optimize energy consumption. So we can optimize the energy consumption by identifying energy intensive processes. Energy intensive processes is the first step. We can say we have to first identify what are the different type of energy intensive processes we have. Then we should implement certain energy saving technologies or practices. And we should continuously keep track and analysis of energy usage for a proactive adjustment. See, we have an era where environmental concerns are at the forefront of the entire throughout the global discussions. And manufacturing industry, and especially the smart manufacturing industry, has recognized the need to embrace these sustainable practices. green manufacturing or sustainable manufacturing, this has emerged as a key player in shaping a more environmental friendly and socially responsible future. So, uh, we have energy efficiency technologies, either in terms of increasing the efficiency by using the energy efficient equipment, or by doing the process optimization, or by using the smart monitoring system. So if we talk about the energy efficient equipment, we are talking about the machinery which are very high energy efficiency ratings, which can reduce the energy consumption. In process optimization, we mean that we should streamline the manufacturing process so that energy can be minimized through waste reductions or reducing the waste. In smart monitoring system, we are talking about the digital system track energy consumption in real time world, so that we can implement this in smart building system so that we can optimize the energy consumption. Again, we can use the automation and robotics in automated process control, in energy efficient design or data driven optimization. So robots which can operate at optimal energy level, which help us in reducing the waste and inefficiencies. Robots are designed with energy saving features such as regenerative braking system. So this will help in reducing the energy and making it more efficient. Robots can collect data and analyze data to continuously improve the energy performance. So we can take the leverage of automation and robotics to implement this process. Then data-driven strategies for energy management. As far as data-driven strategies is concerned, we can do the real-time tracking of energy by energy monitoring system. We can analyze energy consumption patterns by the help of the big data analytics. We can use the predictive modeling for forecasting future needs so that we can optimize resources allocation and scheduling. So we can see that all these smart manufacturing practices are ultimately help us in reducing the waste, increasing the efficiency, minimizing the waste, which ultimately lead us to the sustainable practices. Then another thing is the innovative technologies can be used for energy savings. Either we can switch over to renewable energy, which we have just discussed in terms of solar, wind, geothermal, or water, hydro. Then we can also go for energy storage systems, where we can use batteries and other storage solution for consistent energy availability by reducing its inefficiencies. We can go for the smart grid integration, where we can connect the smart grids by enables optimized energy consumption and grid stability. Smart factories is one of the very important technologies for the sustainabilities. In smart factories, we are using sensors, collecting data, real-time analysis is done. We can go for the automated process control. We can use the real-time data analytics to predict the advanced failure by reducing the downtime and minimizing energy waste. So ultimately, the entire smart manufacturing, either in terms of the smart factory or data-driven technologies, all these are helping us in reducing the waste, increasing the efficiency. So we can say the initial investments in these smart manufacturing are quite high, and that can hold industrialists or businesses from initiating the process. But the cost of new equipment, infrastructure, and training can be beneficial or profitable in the future time. So changing from traditional to green manufacturing methods require businesses to once again evaluate every production stage, and that can be a great task. So Till now, we have discussed a lot about the environmental impact of traditional manufacturing and how we can switch over to sustainable manufacturing, and especially in case of a smart manufacturing. But along with this, we have just discussed the number of benefits of sustainable manufacturing, which help us to increase the efficiency also. But there are significant challenges also to implementation. And one major hurdle in implementing the sustainability is the high initial investment. Either we talk about the green technologies or the infrastructure, everything requires a huge amount. Then high cost is one major factor, but the another important factor is the lack of expertise, especially in sustainable manufacturing process, which make it difficult for companies to implement these solutions. So there is a shortage of skilled persons with expertise in sustainable manufacturing practices. Then another important challenge is the market demand. That consumers, there is a still resistance to pay higher price for sustainable product, which limits the market demand. Consumers may not always be willing to pay a premium for sustainability produced product. This thing is rising day by day, but still it's not that much. And this becomes one of the important challenge in sustainable manufacturing. So when we are talking about the barriers which are there in adopting sustainable practices, then cost is the most important parameter. Higher upfront investment in sustainable technology. The initial investment are quite high, which can hold back business from initiating the process. Then other barriers are technology, regulation, and consumer demand. So how we can overcome this cost hurdle, which is the one of the most important barrier? Long-term saving. By reducing energy and resource consumption, we can reduce the operating cost. Government plays an important role. Government incentives like tax breaks, subsidies, and grants for sustainable investment can also help us in overcoming the cost hurdle. Improved brand image, attracting environmentally conscious consumers, and enhanced competitiveness, which gaining a market advantage in growing sustainable hurdle. Next is the technological limitation, expertise limitations in sustainable manufacturing. Changing from traditional to green manufacturing methods requires businesses to once again evaluate every production stage, and that can be a daunting task. So either we are talking about the recycling or the selection of the material or the energy efficiency. We have to improve recycling rates and reduce reliance on the virgin material. We should develop renewable and sustainable alternatives. By implementing energy saving technologies, we can come through this technological limitation also. As far as regulatory and policy challenges are
Ma'am, your voice is not audible.
Sheetal ma'am, your voice is not audible. Please check.
I guess, sir, there is some network issue. Ma'am, have you rejoined, please? There was some network issue, I guess. Sheetal ma'am?
Uh, yes, ma'am.
I guess there was some issue, I think. You by chance left the meeting? And your mic is mute, ma'am.
Dr. Ripin, ma'am, am I audible?
Yes, ma'am, you're audible now.
Okay.
But your screen is not visible, ma'am. I think you
Yeah,
need
just a
to.
minute, ma'am. Yeah, again, I am resharing. Dr. Ripin, ma'am, I am not able to share my screen. I think you have to give permission to me again.
Uh, Ma'am, from my side, access has already been granted, ma'am.
But I'm not able to click on my screen after clicking on the share button.
Ma'am, are you able to click on share button?
No.
Ma'am, well, in that case, I think you need to log out and rejoin again. Uh, Dr. Atul, can you please check? Are you able to click on share button? Dr.
Yes,
Atul?
everything is fine. I think
Uh,
Sheetal ma'am, please rejoin. Then you will get all the says.
Yes, ma'am. Now my screen is visible.
Yes, ma'am, your screen is visible now.
Okay. Okay, participants. So we were discussing the challenges. Sorry for the disruptions. And now the regulatory and policy challenges can be overcome by giving the clear guidelines by the government, by taking initiatives for giving the incentives and supports, and by the international corporations. So another important hurdle was changing the consumer mindset. But if we see the data, this is also key increasing day by day, and one of the data says that the 70% customer gives the preferences to the sustainable products. 50% customers are willing to pay more for the sustainable goods, and 90% customers wants the transparency as far as any information seeking is required at the end of the customer. Out of these hurdles, the main and the most important role is of the government. So government role while drafting the policies and the regulations played a very important role, either in terms of incentives, subsidies, or by public-private partnerships, or by implementing a stricter environmental rules. All these will help in achieving the sustainability in the manufacturing. Earlier, what happens if we consider the government regulations, then early regulation historically is focused on protecting the consumers from the harmful products. Then the rules changes and environmental regulations in 20th century saw the rise of environmental regulation while addressing the pollution, conservation, and climate change. But today, modern regulations, which encompasses a wide areas, which includes technology, healthcare, finance, and cyber security. So there is a need that the government should intervene either in terms of the tax incentives or the environmental regulation or the public-private partnership. As far as the economic rationale for government policies are concerned, that should be economic stable. They should promote the competition and the fair practices by increasing the market efficiency. Government should ensure that efficient use of resources for public goods should be considered, and protecting vulnerable populations and promoting equality. Our government regulatory framework should be such that either the process developing regulations through public consultation, means government should involve the public consultations and stakeholders also while drafting their policies. And once the policies and the rules and regulations are made, then the government should enforce strict rules also for the inspections and investigations. And there should be clear and transparent information which is accessible to both as well as the people as well as the government. So there must be transparency by the government for providing a clear and accessible information. So we see that government plays a very important role. Now we'll come to the what are the future trends in sustainable manufacturing practices. When we talk about the sustainable manufacturing, then it lies in a innovative and a holistic approaches. So when we are transitioning to clean energy sources such as solar or wind, this becomes one of the important future as far as sustainable manufacturing is concerned. So the future trends of sustainable manufacturing, either in terms of, if we talk about the energy efficiency, then in energy efficiency, future trends focuses on optimizing the energy consumption. through process improvements, building automation, and efficient equipments. Renewable energies integration by utilizing the solar, wind, hydro, and other renewable sources to power manufacturing, which reduces our reliance on fossil fuels. Circular economy is one of the emerging trend in manufacturing, where our focus is on minimizing the waste by reusing, recycling the material while making a closed loop and reducing reliance on the virgin materials. Then digitalization and smart manufacturing is one of the emerging trends, which leverage in data analytics, sensors, and AI to optimize resource utilizations. As far as future of governance is concerned, this we have discussed just now, that using data analytics to inform policy decisions and optimize outcomes. By switching to the digital governance so that there can be increase in the transparency, and by integrating environmental and social consideration into all policy decision. So this particular slide helps us to understand the emerging trends as far as the future of governance is concerned. If we talk about the future of the green manufacturing, then we can talk about the innovations by developing new technologies and materials which can help us in reducing the environmental impact and by increasing the energy efficiency. We can go for the collaboration between industry, government, and research institution so that we can advance sustainable manufacturing practices. We can also do something to increase the consumer demand. We can grow the awareness among the consumers and demand for sustainable products by driving businesses to adopt environmental conscious practices. And if we talk about the smart manufacturing, then there are a number of things we can talk about, either in terms of additive manufacturing or the 3D printing, which helps us in reducing the waste by creating the products directly from digital designs. And I think all of you know that in additive manufacturing, our main focus is on reducing the waste. There is no wastage of the material. Then we can go for the Internet of Things, where we are using the sensor and the data analytics to optimize the production process. We can go for the artificial intelligence, where we have the AI powered system, which can optimize resource allocations and all. If we talk about the renewable energy, this we have already discussed. We can go for the bio-based plastics or recycled material. We can opt for the solar and wind power or a hydropower. Circular economy and zero waste production. One of the most important principles to achieve a sustainability, because it focuses on the reuse, reduce, and recycle. So waste reduction, manufacturers are optimizing processes to minimize waste. Product should be durable in nature, that we are focusing on designing products that are long lasting. We can increase the life cycle of the product and reduce the need for the replacement. And this is the entirely closed loop system, means materials are kept in use within the production cycle. They are again reuse, recycle, minimize waste, and maximize resource efficiency. So this circular economy principle will dominate, emphasizing waste reduction and material reuse. Smart manufacturing technologies like IoT, AI will further optimize processes, making them more efficient and less resource intensive. Consumer demand for eco-friendly product can also be improved by making them more eco-conscious, by providing more transparency and labeling, and by embracing the circular economy by reusing. Now, if we talk about the drivers for sustainable manufacturing, Then there are number of drivers which help us in implementing the sustainability in manufacturing. So either in terms of environmental concern, where we are talking about the climate change and resource depletion, which are pushing industries to find more sustainable solutions. Regulatory pressures, where government are enacting stricter regulations on emissions or waste management, and the consumer demands also. If consumers are interested in eco-friendly products and brands, then this will also help us, one of the important drivers in achieving the sustainability in manufacturing. Now, if we talk about how we can achieve this sustainable manufacturing in our future, then by till now we have discussed a lot how we can do this by embracing innovation, collaboration, and commitments. We can create a future where economic growth can be linked with the environmental responsibility. Both things can go hand in hand. And there are a number of examples we have which gives us a very positive results, those who implemented sustainability. A company implements a comprehensive sustainability program with renewable energy integration, waste reduction, and responsible material resourcing. So we can go for renewable energy integration, waste reduction, and responsible material sourcing. We can go for the circular economy principles. We can go for the option for the smart factory technologies. So we can't ignore that businesses can continue functionally only if they remain profitable. All corporate sustainability measures are actually motivated by certain drivers, we can say. So when we are talking about transitioning to sustainable manufacturing, this is, we can say it's not just a practice. It has to become a matter of survival for both the planet and the industry. So sustainable smart manufacturing is a critical path to cleaner and more resilient future. By embracing green technologies, we can create a more sustainable manufacturing landscape for generation to come. So to conclude, sustainable manufacturing is essential for cleaner, resilient future. Sustainability is a journey, not a destination. Our goal should be continuous improvement. We should do continuous effort to making constant advances in our company overall sustainability performances. There is no sustainability destination. It's a continuous improvement. So sustainability strikes a balance between the economic growth and environmental thing. So by embracing innovations, fostering collaborations, and committing to sustainability, we can shape a manufacturing sector that only meets today's demand, but that can also help us or ensure us a thriving future for generations to come. Okay, thanks for listening, participants. Thank you for your attention. I now welcome your questions.
Any queries, participants? Participants, any queries? Well, thank you so much, ma'am. I hope there are many takeaways from your session today. And thank you so much for sparing your valuable time. That too on off day, I guess it's a holiday season, and you We requested you to join and you did that. Thank you so much, ma'am. Thank you so much.
Thank you so much, and congratulations to the entire team. I think today is the last day for the course.
Yes, yes,
Yeah,
ma'am.
so many congratulations to the entire team of the
Thank you
college.
so much.
And thank you all the participants also. Thank you.
Thank you, ma'am, for the presentation.
Thank you. Thank you.
So our next speaker of the day, Dr. Shahnawaz Khan, is already present here. Dr. Shahnawaz, am I audible? Dr. Shahnawaz?
Hello, can you hear me?
Yes, 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 sir. So
Good
Dr.
afternoon, everyone.
Dr. Shahnawaz is Head of Applied Research, Associate Professor, Technical Consultant, School of ICT, Bahrain. I welcome you, sir. Dr. Khan is distinguished academic and industry leader with nearly 2 decades of experience in artificial intelligence, blockchain, and Islamic fintech. He has held leadership roles in esteemed universities and various IT companies across multiple countries. With over 70 peer-reviewed publications, 2,000 plus citations, 4 patents, and 7 edited books, Dr. Khan is a co-founder of a vocational institute and 2 IT companies. Passionate about fostering innovation, Dr. Khan leads team developing AI-driven solutions to global challenges. I believe that your session will greatly enrich the participants, offering them variable insights and practical takeaways. Sir, we are honored you to have amongst us. Over to you, sir.
Thank you very much, ma'am, for having me here. Yes. Thank you very much for having me. Should I share the slide?
Yes, sir, sure.
Okay, thank you. I hope it is visible, right?
Yes, sir, it is visible, sir.
Okay. Is it okay now?
Yes, sir.
Okay, thank you very much, everyone, for having me. My name is Shahnawaz Khan. I'm Head of Applied Research at Bahrain Polytechnic in the Kingdom of Bahrain. Today I'll be discussing about digital twins technology in manufacturing industries and some virtual models for real world operation. Actually, we have been working on one digital twin project for manufacturing. So I'll be discussing some details about that project. I'm from artificial intelligence or computer science background, so I don't have much knowledge about manufacturing industry. But this project I took, it was interesting project, and I worked with the other team from our mechanical engineering department and manufacturing engineering department. So those people helped me in developing the physical part or the components of this project. And then I was mainly working on the AI, or you can say the predictive modeling part of the project. So I found this very interesting. So I got involved in this project, and then I start working on this digital twin technology. And then I came to know about this, that how we can implement this in manufacturing. So I'll be just sharing my experience in the development of this project mainly, and what knowledge I acquired throughout this project. So this is the topic or the context of this talk. About me, I did my PhD from IIT BHU, Varanasi. I think you might be aware about that. So my topic of research at that time was mainly natural language processing. I start using a neural network or deep learning at that time. And that has been my interest since then. And I got more interested in applying artificial intelligence and machine learning in different areas. So that's why as told you about fintech and blockchain. So that came from there only. So my research was in fintech, was also application of artificial intelligence and machine learning technology in developing the fintech applications. So once again, thank you very much for having me. And so today we are going to discuss very briefly about just the basic concept about digital twin technology. So we'll start from the very basic topic, that what is a digital twin, then the importance of digital twins, like for example, what are the issues currently in the manufacturing industries, what are the needs, and what benefit we can get out of digital twins technology in manufacturing industry. Then history of digital twin, that means how digital twin technology actually started. Then some of the key features of digital twins. Then we'll be discussing about the role of IoT, Internet of Things devices in digital twins. Then different levels and types of digital twins, some application of the digital twin technology in mainly focused on the manufacturing industries where we can apply, and then one conceptual model and the design that how if you want to create your own digital twin, so what are the actually things required for you. Then I'll be discussing detail about our project, then some of the softwares which are professionally used in industries. So I'll be just introducing the software. I will actually, unfortunately, on this today's holiday, so I don't have the office laptop with me on which the software is installed. So I will not be able to demonstrate the application, but I'll be showing you discussing that topic, softwares actually, and some challenging and future trends. So that's the overview of our talk. So what is a digital twin? Anyone have any idea? Hello. Am I audible?
Yes, sir. You are
Yes,
audible.
sir. Yes, sir.
No
Okay,
idea, sir.
so no idea. Yeah,
Yeah.
actually, I wanted to know that whether you know about digital twin or no, so that I can discuss in that view if you have any idea or not. Okay, so I think most of the people here, they are unaware about digital twin. It's very simple concept. Actually, like for example, when you do, you are mainly from which background, like in mechanical engineering or what
Uh,
background?
so we have participants from
Mechanical
various
engineering.
backgrounds. Mechanical, we have from computer science engineering, we have from management also, sir.
Okay, that's good. Okay, thank you very much about for this information. So, digital twin is not only in manufacturing industry or in mechanical, it can be applied in any of the field. Even nowadays, I think this concept has been very widespread, and even there has been research going on in in the direction of creating a digital twin of a human being. I think there are several videos. I was just searching on YouTube. So there are several videos as well in which like they have kind of shown that how to create a digital twin of a human being. So there are some celebrities for which they are trying to create a digital twin of those people. So that means they will be having similar characteristics, or you can say the ideas or the way of thinking, that how a particular person thinks. So the same, their computer model will also think in the same way. So as the word suggests, digital, right? So that means it's something related to the computer, and twin, that means it's a replica. For example, that's what we consider, right? When there's two, like for example, in twins, we consider there are two people which has been born at the same time, right? So the same thing we try to do or replicate that particular word here. So digital twin, in short, we can just say this is a virtual replica of a physical asset or a system or a process or component. So that means it can be created for anything, starting from a very small component, and you can say the entire system or the entire, or you can say plant. Okay, so a digital twin is a virtual representation or digital counterpart of any of these things. In 2018 by Q and Tao, it was highlighted there are three main concepts which define digital twins. One is the virtualization of the physical entities. That means for whatever things we want to create a digital twins, we have to create a virtual entity of that one. For example, this mouse, if I want to create a digital twin, so I have to think about the functionalities of this mouse. So for example, it has three buttons. So that means in the virtual entity or in the computer, I have to create a model in which there are three entities. Okay, then materialization of the virtual process. That means, for example, the process, like for example, there are three buttons, so I can click all those and then they have some different function. So I have to do the same thing in the virtual or computer model as well, that there those three buttons, I should be able to do click on those buttons in the computer and they should perform the operation as well. That means, for example, those three buttons, they should reflect that, okay, there is a this rolling button is also there, and there is a right click and left click button is also there. So same functionality should be there in the computer as well. And then integration between the reality and the virtual world. What does it mean actually? That there should be some kind of relation or communication between the physical entity and the virtual world. That means the computer model. So that means if you want, if there's some change in the physical model. So for example, if I click here on the left button, so is digital twin should be clicked at the same time in computer model as well. That means whatever we are doing on the physical entity, same operation are being performed in the virtual entity as well, and vice versa. That means if we are doing some operation on the virtual entity, so we can transfer that on virtual. There is another layer that there are two options. You can say that either we can transfer or reflect those operation in the real world, or we can just do the analysis. For example, if you want to see that what will happen in this kind of scenario, like for example, what if analysis or some kind of other operation or prediction we want to do. So on computer model, we can have that as extra layer, but at the same time, if we want to go at the basic level, that we can transfer the operation from there directly in the physical world. So that's the overall concept, or you can say the ideal situation in which we want to create a digital twin. But these operations or these features, they are not available on all the levels. So that's why we have different level of digital twins, and that's why we have different types of digital twins. Okay, excuse me, let me put my phone on the silent mode. It will keep disturbing otherwise. Okay, so is the concept clear? I'm sorry, I try to interact during the lecture so that I will know that you are awake and you are into the lecture. Okay, so when we are creating a digital twin, so we are using real-time data. Real-time data, how we can collect real-time data from the physical asset into computers? Any idea? Hello? No idea. Okay, but then the simulation and the modeling techniques. Okay, so the thing is that we try to mirror the behavior. That means we try to reflect the behavior, characteristics, and the performance of the physical entity into computers. Okay, so virtual replicas of the real world digital twins, they enable a live bidirectional data connection between the physical and digital world. That means we can send the data from both direction. Then the data which we have based upon that data, because this data is in computer now from the physical world, right, or from the entity. So that means we can do all kind of operation. We can do, like for example, all kind of analysis, or you can apply AI algorithm, or you can use that data into Excel, for example, and perform different kind of operation or statistical analysis. So all those things can be done. And at the same time, because we have this data generated from the physical entity, that means real world data, so we can utilize that data for planning, for designing, and for different kind of stages of a project project. And then we can also support the entire life cycle of the project with operational data to ensure the performance and the accuracy of the project or the system or the process on which we are for which we are creating the digital twin. Digital twin technology, it offers virtualization, a virtual representation of the design, manufacturing, and service phases of a product. That means for any of the phase of the product, whether we are in the design phase of the product, we are actually manufacturing that particular product, or we are providing the after services, like the services of the project. That means when the product has been done and it actually is in the actual world and is being used. So at that time, if that particular product requires services, so we can simulate that type of behavior as well using digital twin technology. So with the concept of the twin, in industry 4.0, it is being used a lot nowadays, and there are chances and even the research of market studies as well, which are indicating that in future it will be quite common in almost every industry. So it can enable an exacting description, optimization, prediction, and management of the entire fabrication process. You know what is fabrication process, right? I don't know. But so what actually it can do, that for the entire process, fabrication process, we can do the exact replica of that process in computer. Okay, what is the advantage of doing that? Because when you are doing the fabrication, when you are developing something or when you are manufacturing something, so in real world, there might be that after some time, the tools or the devices or machinery or even the material being used in the development or in the manufacturing process. So because of wear and tear of those tools or because of some environmental conditions, so there might be some problem in the process, right? So if you have a digital twin of that particular environment or the fabrication process, so what those information are being continuously transmitted to the digital twin, and in computer based on using some AI or machine learning algorithms and other analysis, you can identify, like for example, you can identify that okay, the bearing of a particular gear has been is worn out. So you need to change that one. So in reality, you might not actually know that thing because in that case, you might have to analyze that one. But if you have the exact information on computer as well, so computer can easily identify those things. Okay, so that's the one of the advantages. Then the effectiveness of these digital twins, that how effectively it can identify that a particular bearing has worn out, it will rely on the accuracy and the completeness of the underlying model. That means how well you created the digital twin. That means the computer model which you have created, how much detail you have provided there, and how much real-time data you are providing there. So more detail about this thing, that it enables real-time visibility and the synchronization across multiple plants. This is also another advantage. Let's say, for example, there's an industry which has multiple plants across the country or across the globe. For example, there is one plant in India, another plant in Bahrain or USA or China. So if it has multiple plants, so using digital twin technology, what you can do, that you can synchronize all the plans together in the computer model, and it will be easy for you to see that what's going on in one plant and what's going on another plant, and which will help you in enhancing the decision making process. And means if you have to make any changes in any of the plants, so it will be quite easy for you because you already know that you are already aware that what's going on in one place or another place. Same thing it can do for in another industries as well, for whether it is manufacturing industry, healthcare, transportation, energy, or if you want to perform or you want to optimize the performance, or you want to monitor the operation, so it can help you there as well. Okay, so and same thing in the construction as well. For example, when you are designing new buildings or when you are constructing new buildings, or so it can help you there as well to get the, like for example, information about the environmental data, or like ventilation, air conditioning, all those stuff or information can be transmitted to the digital twin, and then you can analyze whether the resident of those building, when they have been developed and when the people has moved into those building, whether they will have a pleasant stay or not, or what kind of problem they might face. So all those things can be analyzed even before you start the construction. Okay, so this technology can be used in almost every industry. Some like why we are actually trying to use this technology in different industries. So there are some issues with the traditional manufacturing methods, or not only the manufacturing method, in almost every industry. So they rely heavily on the accumulated experience of the people who are involved on those in these industries. They rely on the manual labor and the partial automation of the systems as well. So which frequently result in extended production cycle. You see that there, for example, that particular project has you can say the time spent has increased. So especially in the construction industry, you quite often see that the time means when the building's supposed to complete, it completes after 2 or 3 years of that one. So, and because of that, because the time has increased, so the cost will also increase. And then there's an inefficiency in almost every process. Then their deployment can be hindered by implementation cost as well. Means when you are implementing digital twin technology, so in that case, there might be problem because of these three cases. One is the implementation cost, because when you are creating the computer model, so of course you need to require an expert, you require some software which will be used in creating those models, and at the same time you also require some sensors as well, which will be collecting the information or data from the real world. Then data integration issues that's related to the sensors, means how you are going to collect the data from the physical world and transform that data into the digital world. Then you need, of course, a specialized skill or expert people who actually know how to create a digital twin. Okay. So the need, what is the need means, why do we need to create a digital twin? We are actually doing fine in construction and in other industries or manufacturing industries, right? So the need is because of the demand for high precision. That means the product which we are creating, we try to be highly precise on those. Then high value complex industrial products, means there are some industrial products which are very complex to design, and because they are very complex to design, so there are chances that there might be some problem or issues while designing those products or while actually creating. So in that case, means that sometime, let's say one product goes wrong, so the cost will also increase for the other products. Okay. So to support the production planning within a multi-plant environment, when we have multiple plants, so in that case, planning can be easier using this one. Then provide real-time feedback, because we are directly connected with the physical asset. So we can, if there's some problem, so the computer can detect that in advance. So it can monitor the performance, it can identify the potential issues before they actually occur in the physical object, right? And so that means you can say it creates the entire process more reliable and more durable, and at the same time more safe as well. So to optimize the process of the physical system by simulating its behavior and identifying areas where we can make the improvements in the actual system. Then also, when we have the model, so the model can anticipate and improve the product and manufacturing process almost in every industry, like green energy, aviation, in healthcare, automotive. Then engineers and designers, they can test various scenarios, especially here I'm talking about what if scenario, that you can do what if analysis on the digital model or digital twin, and there will be no change in the physical, because you are just doing testing in the digital environment, and you can select, okay, that a particular case which is more beneficial, and then actually implement that case on the physical environment or physical prototype. Okay, the benefit of using digital twins, they provide benefit almost every stage of the product's life cycle. starting from the very beginning, that when you even conceptualize the product, until the very end when you actually sell the product to the market, and even after that when it is in the market, it's actually in use, and if you need to offer after service, so you can also do those things as well, or did get benefit from their using digital twin technology. So almost every stage, whether it is project coordination, design optimization, operational efficiency, time and cost saving, and future proofing and sustainability. So it offers both short-term and long-term benefit. So in short term, it can benefit like based upon the operation, providing a single source of truth. That means it can help reducing the cost, shrinking the risk and uncertainties, and at the same time maximizing the efficiencies. During the discussion, if at any time you have any question, please feel free to ask, or anything which is not clear, you can discuss with me, right? Everyone here?
Sure, sir. Sure.
Okay, thank you. So for owners, it can benefit them in case of making a smart decision, better return on the investment. For manager, they can run the operation smoother, right? And then the maintenance will become easier. And in eco-firms, architecture, engineering, construction business, it can create more values. That means more business. So that means for all the long-term value will also increase using this one. So benefit also include what if analysis, which I already discussed. Then in the manufacturing field, digital twins, they can be seen as a virtual representation of any of the things, like for example, a process, personal, product, asset. Okay. So which are updated in real time as the physical counterpart changes. What does it mean? That means if there are any changes in the process, and we are directly synchronizing that process with the digital twin. So if you make any changes there, or there are any changes because of the wear and tear of the tools and the components or the parts of the machine, so it will be reflected in the computer. Same thing, personal, you can also do the personal digital twin as well. That means how many people are there, so if they are changing, so the same information can be reduced or reflected in the digital twin as well. Same thing with the product or asset. Okay, so you can do a better R&D, and so if there is better R&D, so that means the efficiency of the entire manufacturing process or the fabrication process, it will also increase. So a digital twin, they can eliminate the need for physical prototypes. That means before actually creating the entire actual machine. Sometimes people, companies, they create a small physical prototype to discuss with the client whether this prototype is fine, and then they actually go for the implementation. So if you have a digital twin, so this part can be eliminated, and this part will be faster as well, because creating a digital twin, or you can say the computing model or virtual model, is faster and less cost and time consuming than actually creating the physical prototype. It also reduces the development time as well, because there you can do the analysis, and you can also identify that which particular process can be improved, and which will reduce the development time. Then it also improve the quality by combining multi-physics simulations. Then you can do different type of simulation, and you can identify that, okay, which is the best kind of product in which scenario, or by combining which features. So you can do that. And also you can do data analytics and machine learning to demonstrate the impact of the design changes. That means if you make a design change, so you are not actually changing the physical product, you are just changing the virtual product, right? So the changes will be reflected in the virtual product, and you can identify that which change will make the product better, and you can utilize that one only. Then user scenarios as well. Then that means you can test it under different environmental conditions, under different scenarios, and then you can see that you can see the effect of those things, right? And you can actually tell that, like for example, include those in the description, that okay, these are how it should be used, or how it will work in this type of scenarios. Okay, so they bridge the gap between the physical and digital world, and then they offer digital twin offer powerful framework for gaining insights, optimizing the performance, and driving innovation across almost all the industries where there is digital twins can be implemented. Okay, so customer also get benefit from there because customer immediately realized improved access to the data. Because, for example, if you have done different kind of testing, so whatever the test you actually got successful and you implemented in your physical world, you can just publish those to the customer. So like even the product is new, so you are actually giving them the scenarios that how it should be used or how the temperature will affect this particular product and other kind of features which you have tested. You can publish those, so it will be useful for the customer as well. Okay. So more informed process change decisions, like for example, with potential savings, improvement in the maintenance and operational efficiency, better design, and in some of the cases, it has been seen that using digital twin, 80 to 90% of the cost which occurred during the production, it can be reduced. Then safety training, quality assurance, quality controls, all those things can be managed using digital twins. So that means during the training, you are actually doing it digitally. So if the person who's using that particular machine, he's very new, he doesn't have any experience. So even if he make any mistakes, so there's no harm to the machine and as well as to the person. So if they have done a training multiple time on the digital twin, so they might get some you can say expertise, and then those people can actually start working in the actual industry or actual environment. Okay, same thing can be done with the maintenance and operations. History, how the digital twin technology actually started. Digital twin technology actually started in 1960s with NASA. So they initially applied this technology to monitor and predict the performance of the spacecrafts. And it was actually very broad concept at that time. So what actually they did, they created two identical space vehicles, one which actually traveled to the space and another was at the NASA facility on Earth only. So then they simulated the behavior, means whatever changes are going on in the spacecraft, which is in the space. So they were making those changes on the physical replica which they had at NASA facility. So that means if there are any issues in the space, so they can replicate those issues in the physical entity which was on Earth. And based upon that, they can troubleshoot that one. And the people or the scientists who are in the actual spacecraft, they tell them or communicate them the best case scenario or the best possible ways that how to overcome those problem or issues which they are facing. Okay, so they actually did this for the Apollo 13 mission. They actually there was some issue in that particular spacecraft, and the scientist, or you can say uh, astronaut, they were strangled there in the space. So they created this replica on NASA facility, and they rescued those people just using this particular technology called digital twin. Okay, so through the connected twins, mission control was able to quickly adapt and modify the simulation to match the condition of the damaged spacecraft. The Apollo 13, it was damaged. So they did the same damage on the actual, the physical replica, which was in the NASA facility. And then they come up with the troubleshoot strategies to bring the astronauts safely back home. Okay. So in the it was done in 1960s. So in the 1970s, then mainframe computers started being used to create the digital twin. Then in 80s, CAD system or AutoCAD came. So they start using the CAD drawing or CAD models for quickly adapting the designs into the systems. Then this concept continued. So in 2000s, there was a scientist, Dr. Michelle Graves. in Florida Institute of Technology. So there's a Society of Manufacturing Engineering conference. So in 2002, there was a conference and he introduced this concept of digital twin technology. So in his concept, he proposed a life cycle management center that is connected with the physical presentation, the virtual representation, and the exchange of information between the two. So we did the project which we were doing in Bahrain Polytechnic. So we did the same thing. Like for example, we created a physical replica of the actual product. Okay, of course the size of the replica was very small, and so we have to scale it down because we were not funded. So so we have to scale it down to very small level, and then we created a virtual replica of that one. That means we created a digital twin, and then we use sensors to transmit the data from the physical replica into the computer, and then we did the predictive maintenance of that particular physical replica. So that was our project. So then it was formally announcing the digital twin software concept as well in 2002. And then in 2010, there was a scientist from NASA called John Vickers. He introduced the term called digital twin. In 2000s, 3D CAD software came, so they start using 3D CAD for digital twin. Then in 2010, more software, like almost every vendors which were having this like CAD type of software, they introduced cloud environment. So in the cloud environment, you can connect those models together on, you can transfer the information. So that was another advantage. Then nowadays, all real-time 3D powered digital twins are available, and there are many software which can help you in creating the 3D model of the actual environment. So creating the digital twin, especially in terms of looks, means how actually the actual facility looks, and the same thing, you can create the same environment, 3D environment in computer as well. It has become easier because of the new softwares. And so means you can actually see that the same environment as you are seeing in the digital twin, and same in the physical environment as well. So because of this, and even the IoT devices, the availability of the sensors and how they can communicate with computers, it has become easier. So that means visualization and decision-making process has become easier nowadays. So the future of this, based upon a research study which predicts that more than 500 smart city digital twins will be in operation by the end of this particular year, 2025. Then again, another study, that market for digital twin supported solution in smart cities mainly, it is projected by almost 6 billion by the end of 2029. And by the end of next year, global digital twin market is expected to reach almost 50 billion by 2026. So that means there are many people or many industries which are investing in this particular technology, and which are trying to create the solution for creating digital twins. Real-time integration. There's a continuous, these are some of the key features of digital twins. That one is real-time integration, that continuous update with real-time data from sensor using IoT devices and other sources can be done. So which will give us real-time data, and accurate representation of physical asset or system at any given time. Any question till now? Or anything which is clear? Hello, are you
Sir,
here?
being a mechanical engineer, this technology of the twin technology for manufacturing is really very new to me, and of course, I'm learning not many things from you. Thanks a lot.
Thank you. Thank you. Of course, it's actually it's quite useful in the manufacturing industries. Though the problem here is actually when I was developing this, I was working with this project. So I found I identified this problem, or you can say the observation when I was working with my colleague from mechanical engineering, that they are good at their work, of course, but they are not much aware about that how to use these software. So in this case, I think if you want to use this kind of technology, the best approach will be to collaborate with some other person from, let's say, computer science, and do interdisciplinary research instead of wasting your time in learning new that how to use that particular software. Uh, this is one approach I think which can help in doing better research. Okay, so some of the key feature of digital twin technology, one is real-time integration, another is simulation and modeling. Simulation and modeling, the same thing, that means we are trying to do some kind of work in the computer environment without actually affecting the physical world or physical asset. Okay, so you can incorporate simulation and modeling techniques in, let's say, MATLAB. MATLAB can be used here. Okay, then simulate the behavior and performance of the physical asset or system under different conditions. That means you can change the environmental factor, the temperature, the conditions, like, for example, the air, wind conditions you can change. You can also put some, like, for example, raining conditions, or all these stuffs or different conditions you can change. Then you can also do predictive analysis. That means in future what will happen to this particular device if the same condition continue for, let's say, 1 month. For example, let's say here in Bahrain, the one thing which we environmental change which we have to take care is the sand. Or you can see, like, for example, here, because first of all it's very hot here in summertime, and second is like sandstorms keeps coming, though it's not actually very sandy, but the air becomes dusty. Okay, so because of the dust in the air, the machine on which you are working, if it is in the like outside area, so the machine does not actually perform well, and because of those dust particles, they start the parts of the machine, they wear and tear very fast than an actual environment. And sometimes, the filter oil which is being used in the machine, it become you can say useless, or it is what you means it worn out very easily or very fast. So these problems happen. Actually, we got one project from one of the local industry, that they were working especially in this excavator or other these type of machine which are used in construction industries. So the company which has developed those machines, they are not able to come up with a solution in the in this area, the entire Gulf area, because they are not aware about the environmental conditions here. So we are working on that particular problem, that how to solve those environmental issues in those machine here locally in Bahrain or in Gulf countries. So this technique, digital twin, give us this advantage, that we can change all those environmental condition here virtually in the computing environment or in the computing model, without actually uh, working on the physical asset, or without actually uh, changing the physical asset. Are digital twins and IoT related? Nowadays, yes. Earlier, it wasn't. So IoT devices or Internet of Things devices, they refer to the network of physical objects that possess unique ID or identifiers and contain embedded technology, for example, for communicating with the internet. Okay, so according to a market research, more than 95% of the IoT platform will offer digital twinning capability by 2029. Digital twinning will become standard in IoT application by the end of 2028, and by 2030 there will be almost 29 billion connected IoT devices. This is one of the prediction according to a market and research. So now these embedded technology, they enable digital twin to communicate and interact with the other object over the internet, because IoT devices, they help us in communicating Okay, so if you plug that particular device with the physical asset, so that means digital twin can communicate with the real world data in real time. So with real time sensor data, predictive recommendation using AI can be made. Then when you are building a digital twin and deploying its feature and closing AI resources, so it will become almost necessary to use IoT devices on the physical machine or physical asset or the component. So IoT can provide insight into the performance of an asset, especially at a particular point of time, and it can also help user to evaluate potential outcomes and plan resources. Integrating digital twin with IoT. So of course, if we integrate digital twins with IoT, so it will allow us to do bidirectional communication. That means from this virtual model into the physical model. And with access to sensor data, sensor and data, IoT sensors and data, digital twin can capture the entire view or holistic view of the virtual model to unlock deeper operational intelligence. So for example, using this one, we can also do, like, for example, an engine might contain information about performance characteristics. So we can get that information in real time. And then it can allow the engineers to run simulation and test new designs or measure the impact of the future changes which you want to make in the engine of that particular machine, for example. The level of digital twins can be categorized in based upon two criteria. One is the level of sophistication. That means how much detail you are going to put into the digital twin. And the second is that means what part. So the first we'll discuss 5 levels of the sophistication, then we'll go to the second part. So the simplest model integrate data from various sources, and most advanced is automatic. That means it automatically collecting the data from the physical asset and then automatically sending the information back, and it's doing everything automatically. There is no human involvement. And the first is just very, very basic, in which you are providing the data. So the descriptive twin, currently it is used in the architecture, engineering, and construction industry. So it's an editable version of the design and construction and visual replica of the built asset. For example, you are creating the visual replica of a building into the computers. So if you are making any changes, so you are providing or manually providing the data. Then another is informative twin. So it has like all the things, whatever is in level 1, the same thing will be available in level 2, plus added feature, which are here. Like for example, one added layer of the operational and sensory data. That means you have put some sensors or operation which are collecting the data from the actual world and sending it to the virtual world. Okay, then it captures and aggregate the defined data and verify the data to make sure that the system works together. That means the virtual model and the actual model, they are synchronized, and they continuously collect the data based upon time interval, which you said that, for example, after every 30 minutes, after every 1 hour, or after every minute, based upon the type of data which you need. And then you can do the time series analysis and get the insight, whatever you want. Then the next level is predictive twin. This is the level on which we have worked. So it can use operational data to gain insight. For example, IoT reading showing you a vibration in a machining device. We actually use this particular one. We use a vibration sensor, which was giving us the vibration of a turbine. And then from based upon those vibration, we were predicting whether this particular turbine require maintenance or not. Okay, so it can warning you that a motor bearing is worn out down before the actually it happened. Then the comprehensive twin, this is more advanced level. So this twin simulate the future scenario and consider what if questions. That means you can, once you have the digital twins, and you can perform what if analysis. Then the highest level is the autonomous twin. The twin has the ability to learn and act on behalf of user. That means there is no user involvement. It's just like at the time when you created the twin. So of course the user will be involved, but once the twin has been created, it can interact with the physical environment by itself. Excuse me. Okay, so the second is types of digital twins based upon the depending on the level of the product magnification. So the biggest difference these twins is the area of application, means where these type of application, these type of digital twins has been applied. Okay, so different type of digital twins, they can coexist in a system or a process. So there are four types mainly. One is the component twins or the part twins, in which this is the smallest, or you can say the basic unit of digital twins, that from the entire system you are just selecting up one particular part and you are simulating the environment, simulating or creating a virtual model for that particular part. For example, let's say you want to create a digital twin of a car engine, right? For example, and instead of creating the entire car engine or digital twin of the car engine, what you are doing, just you are taking the piston and you are creating the digital twin of the piston, that how the piston works when you are using different type of oil. Okay, you just want to check that one. Okay, so this is the smallest level. The second is asset twin. Here, instead of single part, you are selecting more than one part or more than one component. So that's called as asset twins. There are two or more components, they are working together. How they will perform in the actual world and the physical world, and if you are creating the virtual world for those. So this will be called as asset twins. Then the system, that means one particular unit. Okay, you want to see that how that particular unit is working, or the system. So that's called as system twin. And the process twins reveals how multiple systems they come together to create entire facilities. Okay, so for example, you are creating the entire fabrication process or manufacturing process. You are creating a digital twin for that one, or for example, even a complete production facility. So all of those type of twins, they will come under the last category. In manufacturing or smart manufacturing, so because if we are creating digital twins in manufacturing, so it will that particular manufacturing process will automatically become a smart, right? Because here we will be using IoT device for collecting the data and all. There will be different components. So that means the manufacturing will automatically become smart if we are using digital twins. So in smart manufacturing, we can combine real-time data from physical sensor. We can use CAD or any other software. CAD is not the standard here. I've just use the word because mostly mechanical engineer, they use CAD. So that's why I use this particular word here. Otherwise, it's not a standard. You can utilize any other modeling technique as well, or any other simulation tool as well. Then a digital twin, they allow manufacturers to monitor and analyze the performance of the equipments, of course, identify the potential issues before they occur, and make data-driven decisions to optimize the production. Then, of course, with Industry 4.0, it has become more widespread, this particular technology, and is being used in the product life cycle as well. And then by using this technology, nowadays, many of the industries have seen that there is a faster time to market in product development. That means the product are being developed in much faster way, and they have increased their productivity among the workers. Okay, according to Forrester consulting study commissioned by Unity. Unity is a software company which develop software for gaming or 3D virtualization. So they have developed a software for creating digital twin as well. They combine Unity software along with the CAD models. So you can directly import the CAD models from there into Unity and create a virtual or digital twin for that one. So over 80% of the companies who implemented immersive technology identify improvement in their ability to innovate, collaborate in their production, manufacturing, and operation work phases of the production. That means from starting or from the concept of the product till the product goes to the market. Then top use cases of digital twin in manufacturing, that means where we can use digital twin in manufacturing industry. Like one is factory design and layout. That means creating the entire factory in the computer model first, and just then you can see that what will the machine layout, assembly flow, employee interaction. So that means everything in computer first, and do all the analysis in computer, and then once you have that, okay, this is the best layout for the company, then you can go back to the physical environment and then put the machine in that particular environments in which the flow will be best, layout, how the machine has been organized or put in place, that will be best. Okay. Then another is robotic simulation, building fundamentally safer system for training robots in a simulated environment. Then operator training, that means the people who are actually using those machines, training those operators on a virtual machine or digital twin is much safer and much you can say much safer, and you can say very economical as well. Then monitoring or guiding maintenance and repair. That means you can also transform routine time-consuming process into seamless process with remote-enabled AR technology. AR means augmented reality technologies. So here you can teach people how to maintain, how to do maintenance using digital twin technology. Some other application based upon research, like for example, people also has used digital twin technology in product design. They also in production management and control, manufacturing system design, system fault diagnosis, then system risk prevention, production data management, manufacturing system management. So almost every part of the manufacturing industry can utilize digital twin technology. So some more application here, I've just listed them out. You can go through them. Like for example, modeling the entire manufacturing process, starting from the raw material to the final finished product, then simulating different kind of scenario, identifying potential issues. So they are almost same. And not only in manufacturing, the same processes can be implemented in other industries as well. For example, even smart cities or healthcare or energies. So you can utilize almost the same examples here as well. Okay, and these are some more application which I didn't which I identified when I was doing literature review. So I seen that some of the people have been working in these industries as well. Uh, Using digital twin technology, and these are just which I have seen in research. So there might be some more industries in which this technology is being used. So that's why I've written not limited to, because I cannot do the complete literature review. How does a digital twin work? Okay. So they connect the virtual world with the real world asset. We have been discussing this at the beginning. So the data from the virtual world is data is from the real world is fed into the virtual world by sending bidirectional data between the software system and interfaces that connect them. So for example, let's say you have a sensor device on the physical world. So using the sensor or in an internet, you can send that information back to the computers. Okay, or just you need to identify that how that particular sensor works. So every sensors come up with the direction that how you can collect the data using that particular sensor. So just follow the instruction which come up with the sensors, and then you collect the data from that sensor. And once you have that data, you can send that data back to the virtual model. And then once you have the data in the virtual model, you can visualize that model. You can enable cross-functional team to collaborate with you. For example, for example, you are from mechanical background, so you have the data, but you don't know how to do analysis. So you can ask someone from IT or computer science or someone expert in data science that we need to do these things or perform these kind of tests. So you can collaborate there. Then help companies understand the past, view present condition, and prevent future problems. So like, for example, if you have continuous data accumulated over a period of time, so that like say, for example, if you're working in a company or for a particular machine, you have to understand or you have to do analysis for that particular machine. So you can see the past data, you can see what are the current conditions, and then you can predict that what will that if this thing continues, so what will happen in future. Then you can team inform this make informed decisions. Okay. In construction also, it works in a similar way. So this is the general working of the environment. Then how in the construction environment, how does it work? So it works in almost in the same way. Just the thing is that the type of data which you are collecting, it will differ in each type of environment. So for example, if you are working in the construction industry, so the type of data you will be collected might be heating, ventilation, air conditioning, mechanical, electrical, plumbing system. So you might be collecting this type of data. If you are working in manufacturing industry, so then maybe the type of data which you will be collecting, it will become different. Okay, so the type of industry just define the type of data which you will be collecting. Rest of the things or rest of the technology or the process, they remains the same. Okay, so parts and maintenance, environmental data collecting through IO sensors. So it doesn't matter what industry you are working, digital technology can be applied there. Just the thing is that you should be aware that what type of data is affecting my model or affecting my machine for which you want to create a digital twin. And you should be aware that what type of analysis you want to do. Okay, anyone has any questions before we move further? No questions? I know. I think everyone is tired because you have been doing it for 6 days, and today is the last day, right?
Not exactly, sir. Actually, earlier I was having one question when you were explaining the slide on the predictive twins. But now you have explained a lot about it. I was thinking that how IoT reading or the sensor reading gives us, no doubt, gives us the various data and how that data can be used by the twins for analysis of the data. But now you have well explained, sir. Thanks a lot, sir.
Okay, thank you very much. Okay, I'm going to explain the same thing actually now in the next slide, because next few slides. Okay, so the digital twin model, this is just one, you can say the conceptual design. So it's like, for example, you have a building. So in also in the virtual space, you can create a same building there, a replica of that one. And then like, for example, you have sensors here, which are transmitting the data here. So for example, if you turn on the light here, so the sensor will transmit the data and then the light will be turned on here as well. Okay, same thing, for example, there's a wind turbine, you are getting a wind turbine here as well. So whatever the speed of this turbine is here, so the sensor will send that information back to the virtual model, and the wind turbine speed will be the same for this one as well. So once we have the wind turbine speed here, so we can calculate that how much voltage is being generated. Okay, and then for example, if we know the weather condition as well, so we can collect the weather condition from the for example, weather.com. Okay, so we can collect that what will happen in future. So we can analyze in advance that how much if the weather is changing, so what will effect will happen on this physical asset, and then we can take the precaution in advance. For example, if let's say if the weather prediction says that there might be storm, right? So we can do prevention in advance from here, right? And we can also simulate that environment here, that okay, what is the speed of the wind will be in the storm, and then if we simulate that behavior here, we can see, okay, let's say that that particular speed, whatever will be their maximum speed in the storm, and if it doesn't change, doesn't affect any way to the wind turbine, then we don't have to take any prevention here, right? So those things can be calculated in advance using the digital twin models. Okay, so this is very basic one. A little bit more advanced concept or the design of this manufacturing process. So for example, this is a physical environment. So here we'll decide that what type of perception we need, what type of information we need. Then we need to connect that to the virtual world. Okay, and then what we will do that these things using the sensors, okay, and Internet of Things, will transfer this information to the digital environment. In digital environment, we got this data, so we have different thing there. Like, for example, we can do prognosis, we can do data fusion, diagnosis, or other things. This is like using AI or machine learning. This is just some words which are written here, but doesn't mean these are the things there. So here, whatever you want to implement, you can implement all those things in the digital system or in the virtual world or on the digital twin. And then information, whatever you got after the analysis, you can transfer that information back to the physical system, and then you can make either redesign or do the maintenance, right? So this is one system, one way of doing the things. Another can be this one, like some more detailed version of the how you can create the digital twin. So you can see that, for example, what we did that for each physical entity, we are creating a virtual entity and we are mapping those entities. So if there are any changes here, so those changes will be reflected here, and we can do all kind of analysis in virtual world as well. Okay. Then a more detailed one, framework for manufacturing process using augmented reality. You can do that as well. So here also you can see that we have physical products here. So at the same time, in the virtual world, we have digital twin products. So whatever is here, we are just creating what I wanted to demonstrate using this one, that it doesn't matter which approach you take, is just one thing you have to do, that first, you have to create the exact replica of the physical asset into the computer world. The second, you have to make sure that the data which you are collecting, if this is the exact data, that means there's no no problem with the data collection. If there's issue, so you can adjust the environment in a way that when you have the actual readings or actual values from the physical world into the virtual world. That's the main thing. This is the our project. So we created this physical replica of, this was a wind turbine. Okay. Not wind turbine, like here there is a company called Aluminium Bahrain Alba, one of the largest aluminium company in world, or actually I think largest in Asia. I'm not quite sure, but I think it's. So they have this process, and they have different type of turbines, and those turbines, they are usually in the outer space, and people rarely go there. Okay, so in that case, what happened that sometimes those becomes like the bearing in those, it becomes worn out, and if the person is not going there, so in that case, if it becomes bad, so it will destroy almost the entire turbine, right? So what like when we got this information from their representative. So they said that if we can come up with a solution in which the people don't have to visit the turbine, and still they can predict if the bearing needs to be changed, so it will save them a lot of cost. So what we did, we come because we can't actually perform experiment on the live machine, right? Because it actually is in the implementation. So what we did, we created a small replica of that particular turbine here in our parent Polytechnic. We attach the motor and we run at the same speed on which that particular actual turbine runs. We attached a sensor to this machine because we want to create a solution in which there is a minimal changes to the existing environment. So what we did, we create kind of plug and play, that you don't have to make any changes in the actual environment. Just put this particular device on top of the machine, or either weld it, or just actually we did a magnetic base. So it's just like attach like put a magnet on some kind of on any kind of machine. So on this turbine, we put this magnetic device, which actually like collect 2-3 types of information. The main thing which we did was this vibration, because if there is a problem with the bearing, so that means there will be vibration, right? So we collected the like the values of the vibration, and those vibration, they were transferred over a interval of time. So we tested that, like for example, we did testing on per hour. Then we also did per day as well. We also did per 6 hour as well. So different type of data we did. So that's the what if analysis, that what will happen if this thing happen or that. And then when we had this all data, so we also like luckily we got their past data as well, when the accident happened, that how much vibration they were having when actually the turbine went down. So we got that data as well, or kind of information from there. So based upon that data and the data which we collected, we created an AI model, machine learning model, and that learning model was able to predict, and then we manually change the bearing from perfect bearing to then some worn out bearing, and then some more worn out, and then one very bad bearing. Okay, so that we can get the data in each type of environment, right? And then we created the model, and then we try to do create a screen is not visible.
It's visible.
It's visible,
Okay.
sir. It's visible.
Okay, so then that model was able to predict that, okay, if there are any changes in the vibration, so it can predict that if these vibration will lead to the turbine failure or not, or if just you need to change the bearing, or all those kind of things. Okay, so this is like, for example, this is the physical model, but at the same time, this is the physical replica, small replica, scaled down. But we also created one digital twin as well. That means the same thing we created into the computer as well. And then there are all kind of analysis which we had to perform. We did there actually, not on the actual machine or actual replica. Okay, so of course, now once you create this type of environment, so you need to like, these are the steps which you need to actually develop. So first, for example, data acquisition and integration. So you need to collect the data. So what we did, that we use sensor and IoT devices to collect the data. Now this data is coming from different sources. So for example, coming from sensors as well, but this data, I used some other terms as well. So this data can come from program logic controller as well, or from SCADA as well. So, or from wherever this data is coming. So you can use different multiple sources. This, we did not use the second part, but I included this so that you should be aware. So, so we collected data from different, you can collect data from different environment. And once you have the data, you need to clean that data and pre-process. Why we need cleaning? Because when you are working on machine learning models or AI models, so they need good data. Because if you are providing data which is not clean, or which is not which is not perfect, so the outcome will not be good as well. And sometimes the algorithm might make mistake as well. So it's better to clean the data first and do some pre-processing on the data before you actually start training the model. Then once we have the data, so the data is clear now. Then the physical, sometimes physics-based models is also needed. What is physics-based model? That, for example, how in this particular environment, uh, how the machine or physical asset will behave. So that particular behavior, if you can come up with a mathematical equation for that behavior, okay. For example, here what I'm saying, mathematical equation. For example, you have a temperature, right? Temperature data, or let's say, for example, wind data. So how it will affect the model, for example, how many changes will happen in the actual model. So if you can come up the physics behind the changes in the physical asset, so you can replicate those changes into the virtual world as well. So here we did not actually we could not do many of the things here. So what we did, we only did one change, and that was the vibration. So that means we were just changing the vibration data by using factors. Okay, so it wasn't actual values which we can get. So we start changing the factor. For example, what we did actually, we from the bearing, we removed one ball. Okay, and then we calculated the values. And then what we did, another thing, that we put a damaged ball. Basically, the ball was there, but it was worn out. So that means half of the ball was cut, and then it was there. Because of that, the vibration also changed. So we calculated the values, and these values kind of created a physics for us. And then we conceptualize that if there are two balls missing, or two balls are damaged, or three balls are damaged, so what will happen? So the vibration values were changing based upon that, and the same was reflected in the digital model as well, or the digital twin as well. So then once you have these values or these data, so you can utilize any of the machine learning algorithm which you can think that can predict better in this particular environment. So you can test against multiple machine learning or AI algorithm, and then whatever fits best in that particular environment. This can also, you can do in very in advance as well. Instead of doing trial and error method, that which one will fit best, you can analyze the data, and based upon the analysis, if there is someone from computer science with you, so that guy can easily identify that in this type of data which algorithm will fit best. Then once you have all this information, you can also simulate the environment as well. So you have, like for example, for creating the simulation, this should have been the first before we discuss this one. So you can use MATLAB and Simulink, for example. They are quite perfect. So I think you can easily find MATLAB. Even trial version, you can get this Simulink as well. So if you want to do some experiment, so you don't have to pay anything. You can just utilize MATLAB and create your digital twins. Then once, so this is the overall process. This is the only thing which you have to complete. So once you have those things and you have the data, so you can start doing predictive maintenance or the process optimization or anomaly detection. That means something going on from the actual process. So so if there's any anomaly, you can consider that as a problem. So they can be utilized to detect potential problem as well. You can also do 3D visualization. You can come up with a software, entire software for creating the dashboard and the reports that, okay, these things are happening, so this will be the outcome. All those things you can create just if you have this information, or your physical model is aligned with your virtual model. Okay, so there's a software called Unity Industry. This is again from Unity, which develop games. Game software, not the games. So they have developed a one version of their gaming software called as Unity Industry, which help you to create virtual model. So in this virtual model, what you can do from CAD or GIS software or BIM software, you can use those model directly into this software, Unity Industry. And once you import those one, it automatically create your virtual or 3D environment or 3D machine, you can say, for your model. Okay, so that means now you have the virtual environment, or your digital twin. It's not 100% ready, but it's almost ready, just based upon your CAD model or GIS model. And then you can implement more physics and those things, because because of gaming, for example, Unity already have those physics environment already built in. So you can implement those on your machine, on your CAD model. So the physical environment you can create from there. Okay, so you can simulate real world condition there. You can perform what if scenarios or any circumstances, and you can visualize the outcome. Then another software which can help you in creating the digital twin from Autodesk, there's a software called Autodesk Tandem. You can utilize this one as well. So it's mainly for creating in construction industry, for creating the building and other things. So this can be utilized. Then there's a company called NVIDIA. Mainly they develop the GPUs. So they have a software called Omniverse Replicator. So you can utilize that one as well for creating digital twins. Then AWS, Amazon AWS services. So they also have IoT Twin Maker. So you can, this is also very easy to use here because it's a cloud-based model. So what you can do, just go log in into the AWS account. Even I think they have a free trial version of this one. Like when you create an AWS account, so they give you 1 year of free services, right? So in those free services, Twin Maker, I think it comes already. So you can create a free account on AWS for AWS services, and it will be there. And if you already have a CAD model, for example, I think everyone in mechanical, they know how to use AutoCAD. So if you have a CAD model, you can import them into Twin Maker and create a digital twin. Okay, then CAD as well. They have a software for creating 3D models, and then there are simulation software. This is like you can combine CAD with any other simulation software, and then you can integrate. So these are just some of the professional level software. Most of them they are paid, but they are like you have free version of those as well. So like, for example, Twin Maker I think can be the easy one, which you can utilize free of cost. You just need to import 3D model from AutoCAD if you have that one. Okay, so and then from CAD also, from AutoCAD CAD company, there is a software called as SimCenter 3D. So this also SimCenter 3D, it also provide you the complete guidance, even or even the environment how to create a digital twin. Okay, but for example, if you want to do some research or something, so I still prefer MATLAB. So you can utilize MATLAB and Simulink for creating your digital twin. Digital twin, it provide enough facilities that you can, I think, easily create there. Okay. Some other example, there's a South African company, engineering consultants company. This is one of the biggest application for digital twin. You can see that they have this what is the solar field, right? So they created the and it's in the desert, Sahara desert. So that means there are chances that desert sandstorm will be there and there will be too much dust and everything. Okay, so they have created a digital twin of that one. This view is from actually the digital twin. So you can see that you can change the dates here, calendar and time of the date, and then you can still see that what's going on that particular day. You can change the weather conditions here, lighting conditions as well, you can change here. Okay, so they created this one, and they utilize digital twin to analyze the environment and for other situation. Then there is a company called Siemens. They develop healthcare devices. So they created one software called develop production digital twin, and the companies which utilized Siemens product or for creating their own product. So they provided this software to them, and they identified that after they created this digital twin, that the time to the market for their clients has become 30% faster, and almost every month the total production cost they saved almost $2 million within 1 year of production cost. So that means digital twin technology, it helps the companies or the industries in saving the cost as well, and as well as it increase the time to market as well, and it provide different it helps in overcoming different operational challenges. For example, improving the efficiency or quality in the virtual 3D world. And once you have that done in the simulated environment or on the digital twin, you can actually implement the same thing on the physical environment as well, or the actual world as well. Some of the challenges and consideration before we start working in this direction is of course, like for example, digital twin technology, what it is giving us. If we go to the core thing, it's just giving us the data, because we are using IoT devices to or the sensors to collect the data from the actual environment. So now we have the data, but if you don't know how to utilize that particular data, you don't know how to get the best outcome from that data will be useless, right? So means you should collecting data is one thing, but getting something out of the data is another thing. So you should know that how to utilize the raw data so that you can actually utilize the power of digital twin. Until unless you are good with data analysis and data visualization, and then getting the pattern out of the data or getting the insight from the data, then it will not be quite useful. Okay. Then another challenges can become like security and privacy. Because you are collecting a lot of amount of data. So now some data might be very sensitive. So if you don't actually preserve the data well, then some other people, if the other people who are not authorized to access the data, they can misuse that particular data, right? So data security is one of the thing. Then model accuracy and validation. This is also very important thing, that when you are creating the digital model or the digital twin of the physical asset, so you have to be very accurate in terms of the physics and other things which you are creating for the model. Then, of course, skill training and return of investment. This is also another thing, because when you're creating a digital twin, so you will be investing some money into integrating the IoT devices. Then you need some expert who are able to create the virtual model. Then you need some expert who actually need some who actually do the AI and other modeling or data visualization or other things which you want to do with the data. So you will be investing some extra amount of money on that. So now you have to identify that whether you will get the same return from this analysis or creating digital twin or not. So that is another challenge as well. Okay. So the future, of course, it looks bright for digital twin technology. And as I told you that there are many industries who are investing heavily in this direction. And I also told you about that there are people who are creating digital twin of the people as well. So you can search that as well. So there are good direction. This is a very good direction. And then more accurate models can be created using edge computing. That means the more close to the source. So of course, the faster responses will be. Then there can be created digital twin ecosystem. Like for example, we have in future we'll be having IoT ecosystem. That means all the IoT devices, they can communicate with each other, right? Like internet, right? So same thing can happen with the digital twin technology as well. That all the digital twin of different let's say in an organization, if you have digital twin of each of the process or each of the components, they can automatically communicate with each other and have the comprehensive view of the entire manufacturing ecosystem. Then you can also provide AI, you can also utilize AI there. Okay. And then of course in future there so many things can be done. Okay, so thank you very much for listening and giving me your time. I hope I did not bore you much. You did not sleep, I hope. And now, if you have any question, please feel free to ask.
Any questions, participants?
Hello, sir. This side, Shashank. Am I audible, sir?
Yes, yes, Shashank, I can.
Sir, I have a question that you said that the vibrations which are producing because of the fault in bearing.
Yeah.
Yeah, but sir, how you predict or decide that those vibrations are only because of the bearing fault? Because there are many other things also which can produce vibrations, like mass imbalance.
Yeah. Okay. So here, there were two things mainly. First, like from because we got this problem from the industry, right? So they told us that the only cause of the problem in past they have seen is just the bearing, nothing else. Okay. So so that's why we did not have to research that there can be other problem as well. The second thing, why we were sure that is just the bearing, because the condition in which it has been placed, this particular turbine, is very you can say firm condition. So I'll just share my slide here, and the same thing we try to reflect as well. So if you see here, this is very well connected. You see here is very like is fixed. So there are no chances that this environment or this turbine can be imbalanced because of any other factor. The only thing is this pole on which you see this pole is there on which the bearing is there. So the only cause of vibration can be from here, because otherwise it's very hard fixed and there are no chances that there can be any other cause of the vibration change. So that's why we picked that one. But your question is very valid one and very good question. There can be many other causes as well of vibration. But again, when we are creating digital twin, that's why I'm saying that the accuracy should be there when you are creating digital twin, that the physical asset conditions should be accurately reflected in the virtual world. Then only you can utilize this technology. So in our environment, there were no other cause. So we reflected that in our digital twin as well. But if you in the environment in you are working, so there are other chances. So you have to include those factors as well.
Sir, did you publish those results so that I can refer them?
No, it's not yet public. Actually, the problem with us in Polytechnic, we mainly focus on applied research. The problem with the applied research is that most of our problem, they come from industry, right? And sometimes they fund as well
Okay.
those research. So the publication requirement also come from the industry. So, for
Okay.
example, they like when they fund research, usually they tell us that you cannot publish your research now. We will tell you when you can publish.
Actually, sir, if we know the signatures of those vibrations, then
Yeah,
also we can predict that in future that these signatures are because of the fault in bearings. So that's how we can.
I understood your question, but this is like some of the limitation. It comes with the like when you are working with the industry. So some of the limitation, especially because industry is not interested in getting a publication,
Yeah, sir,
right?
exactly.
So they are more focused on solving their problem. So that's why.
So
Yes,
I
Okay,
have
ma'am.
a
sir.
question. While solving these issues in industries, have you ever dealt with like vast non-linearities?
Like,
Like, sir, because every system is like, a non-linear. Whenever we deal with like any kind of subject or if we study, uh, we just take up to one order, specific order. But actually, there are a number of non-linearities present. So are you dealing with those things
uh,
also?
actually, what happens with us, like for example, we deal with different kind of industries. This not always like the problem is not always related to mechanical. So the problem can be related to other industry as well. So for example, I'll give you, we have one project currently on which our engineers are working. I was involved in, luckily I was involved in this project because it was related to AI and my expertise in AI. But
Sir,
we mainly,
can I give the
yeah,
answer of that question? I know, sir. Actually, because although yes,
yeah,
there are non-linearity because in ball bearings, obviously they are non-linear.
Non-linear,
But
yes.
yeah, no bearings are non-linear. No, though the forces which they produce are non-linear. But
But my
I think that sir is dealing only basically on the how to detect the faults.
okay, how
So
to
there is
detect?
no need of going in the modeling of that. You know, I think, sir.
yes, you're right. We were just mainly doing predictive maintenance. That
Yeah,
means
exactly.
we were trying to do that in future there might be problem in this one or not.
Yeah, exactly, sir.
So it was just
Thank you.
predictive maintenance. So yeah, what I was trying to say that I luckily got involved in this project and I got to learn about digital twin technology. But my expertise in AI area, so all the things like all these stuffs, they are dealt by our engineers. So whether this project was mainly handled by the engineers, my task was just developing the AI model.
Any other queries,
Sir, then
participant?
sir, one more question then. How you decide that which machine learning model suits this data which which you have obtained?
Yeah, actually, how did I decide? This is like, for example, we got data, time series data, right? So we start doing time series analysis, and we identify that this regression model, there was one regression model, can fit best in in this type of time series because when we did the visualization of the time series, we identified one pattern that this pattern that whenever there is a problem with the bearing, this pattern occurs or this particular thing occurs. Okay, so luckily we got lucky in that scenario that we like just by our eyes, visualization of the data, we were able to identify that one. But in different kind of scenarios, you will have to utilize different methods that which particular machine learning algorithm will fit in this kind of scenario.
So, sir, is it like some hit and trial method? Matlab, we should go for hit and trial because as a newcomer like me, if I want to,
Yeah, as a newcomer, yes, hit and trial, well, that's the best. Trial and error method is the best method.
yeah, okay, sir.
Yes, Manit, deep learning was implemented. Actually, there's a model called neural autoregressive model, if you heard. So we utilize that one. It was combination of neural and no, not CNN, neural autoregressive model. CNN is mainly for images.
Sir, may I ask one question?
Yes, please. That's why
Sir,
I'm here.
sir, first of all, thank you for the wonderful presentation.
Thank
And
you very much.
sir, my question is that what role does reinforcement learning play in optimizing the performance of digital twins for a complex or dynamic systems such as smart cities or industrial processes? Again,
Okay.
repeating, if you
Yeah,
didn't
yeah.
understand, what
No, no,
role
no,
does
no, no. The question is clear.
reinforcement learning?
Yes, yes. Okay. So, you know about reinforcement learning?
Yes, sir. I am pursuing PhD in machine
Okay.
learning applications in renewable energy technologies,
Okay, okay.
specifically biogas or bioenergy.
Okay. So, your question was, what?
What
Uh,
role does reinforcement learning play in optimizing the performance of digital twins for complex or dynamic systems such as smart cities or industrial processes?
okay, 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 okay. Okay, so reinforcement learning, there are things in reinforcement learning. That means we are providing feedback to the machine, to the learning algorithm when this particular learning algorithm is actually being used, right? And same thing we do in the digital twin as well. That when we are actually developing the digital twin, at that time we need feedback from the actual or physical asset to model the digital twin. So reinforcement learning algorithm can be used, though I don't think that we actually use, but it can be used at that time when you are developing the digital twin. Okay, when you are developing the digital twin model. And sorry again, what was the second part of the question? In construction and in other industries, right?
Yes, matlab in smart cities or industrial processes, how could we utilize reinforcement learning in optimizing the performance of digital twins?
Yeah, this is I think this is the only way, but though I did not work on those area that in smart cities what things you will be doing. So the only thing which you can do is like optimizing the model is the only thing which you can do. I think just learning from the environment. Though I am not like an expert in those areas. Smart cities, I don't know what kind of information you want in the smart cities. So I'm sorry, I'm not very clear about that.
Thank you for the answer, sir. Thank you.
No problem. If you want, I can look into that one, but I'm not very much clear about the smart cities and industrial process. That's what I told in the beginning that, okay, I know about AI, but I don't know about manufacturing and other industries.
Thank you for this wonderful presentation, sir. Thank you.
Thank you very much.
Any other question, participants? Well, I guess I think I should wind up this session. Thank you, sir, for your invaluable insights on digital twins. And your session was actually very enriching, sir. And thank you so much for sparing your valuable time for us. Thank you so
No
much.
problem. Thank you very much for having me here with you. And I think today is the last day. So
Yes,
uh, good luck to you all, and congratulations on organizing this one.
thank,
Uh, Thank you.
thank you, sir. So our next speaker of the day is Dr. SY Siddiqui. He's already present here. Dr. Siddiqui, am I audible?
Yes, you're audible, but
Yes. So I'm delighted to
kind of
welcome you,
audio, I
sir.
just wanted to check if it is okay.
I'm delighted to welcome you, sir. Dr. Siddiqui is a seasoned HR business leader with experience of more than 4 decades. Dr. Siddiqui has held pivotal roles in top organizations like Escorts Limited, DCM Group, Fiat Group, and Maruti Suzuki India Private Limited. A special invitee to Maruti Suzuki's board since 2006, Dr. Siddiqui has also chaired committees such as AIMA's HR Committee and CII's North HR. Currently, he consults select companies in HR and business. With his vast experience in multicultural HR and leadership, I believe that today's session will provide participants with invaluable insights. Once again, I warmly welcome you, sir, and look forward to learning from your expertise. Over to you, sir.
Thank you, Dr. Kohli, and I'm very privileged to be part of this initiative. Thank you to the ATAL team for being in touch with me. I was looking at the previous session, this digital twins, and looking at maybe little imagination of the participant profile. Seems to be very, very kind of expert technical people attending this session. So very privileged to be part of this initiative.
Thank you,
I
sir.
am just starting this presentation on India as the preferred shop floor with the tech and talent advantages. But I'll start this with a small real-time story, which I think is relevant here to share. In 2014 September, I think Honorable Prime Minister Mr. Modi was part of the launch ceremony of Made in India campaign with the Commerce Minister at that point of time, Ms. Sitaraman, at the Vigyan Bhavan in New Delhi. And obviously, there were a lot of invitees from corporates. And the hall was overflowing, so people were sitting on staircases because the capacity went maybe overbooked. They were also webcasting this on the adjoining two halls, but still the crowd was too big for this main hall of Vigyan Bhavan. 10 CEOs from the corporates, including Maruti Suzuki MD, Mr. Kenichi Ayukawa, Mr. Bhargav, Tata Motors, others, Reliance Group. They were supposed to speak before the Prime Minister's final speech on that occasion. And after all the CEOs completed their initial 5-minute kind of address, Mr. Modi spoke for about 1 hour. And in that 1 hour speech, I think it was spellbound, the kind of vision he was sharing for the country and the kind of focus he was trying to bring in the young skilled talent which is available in India, unlike many other countries. And there in that speech, in that 1 hour speech, he mentioned about one company and about one product. And I think you can guess it that it was about Maruti Suzuki and it was about Maruti 800 success in India, changing the kind of bringing a kind of revolution in the car industry in India. And perhaps he was also referring to the future potential of Maruti Suzuki to be able to globally known as a kind of very, very reputed automobile manufacturing company from India. And as luck would have it, 2 years down the line, February 2016, Maruti Suzuki exported Manesar made Haryana made Balenos to Suzuki Japan for the first time. First Indian manufacturer, car manufacturers, exporting India-made cars to Japan. And that was also flagged off by none other than the Honorable Prime Minister, while 1600 Balenos were exported first time to Suzuki Japan. At that point of time, in the Japanese press, this was a big kind of a splash that the company which actually taught us how to make cars starting in 1983 is now, this company is fully capable with the kind of talent available in this company, roughly about 16,000 people at that point of time, to really be able to make cars in India and export them to Japan, the parent company, for our cars to be driven by Japanese customers in Japan. So perhaps when I look at these two kind of narratives, it indicates one very clear thing, is that perhaps in India, we have the kind of talent which can perhaps globally be competitive. And perhaps when we look at a little brief about the session which I am going to cover over the next 1.5 hours, I think I am going to look at the India vision, which is the larger context in which we are going to perhaps look at next 10 years, maybe next 2 decades. We are looking at the external business environment, especially post-COVID. What are the kind of trends and challenges? And we are looking at the talent landscape in India. Dr. Kori, I hope this presentation is being made from your end, please.
Yes, sir. Yes, sir. Dr. Atul, you are requested to share the presentation, please.
So if you can just go back to the second slide, please, where we are talking of the coverage part of this presentation. Just go back. That's it. That's it. So we are going to cover basically the India vision. We are going to look at the external business environment trends and challenges. We'll be looking at the talent landscape in India. Also, we'll talk specifically about the success story of Maruti Suzuki. And then we'll come to the final kind of concluding remarks about India, the tech and talent advantage. Next slide, please. When we are looking at the kind of positive eco environment and an attractive investment destination, I think we are looking at past 10 years consistent, economic growth, very robust economic growth, which our country has experienced, and maybe the economic growth projection for future. Currently, very, very recently, just starting this week, we are looking at a projection of 6.4%, but perhaps potentially we are looking at, when we look at our discussions in the kind of corporate boards, we are looking at 8% plus as we go along. So we are also looking at a very important factor of ever increasing domestic demand potential with good employability and job creation. And here there will be one very interesting thing about 2010, when we crossed a kind of annual production of and sales of cars in India in Maruti Suzuki, roughly about 8 lakhs. Suzuki Japan at that point of time was having an annual volumes of making and selling 7 lakh cars. So we asked our Japanese colleagues that how do you feel? So they said partly happy and partly sad, because the child has now overtaken the parent company in terms of annual volumes. So perhaps this is more driven by our increasing domestic demand potential, unlike many other countries. When we are also looking at the skilled and young manpower availability, we are also very, very fortunate that relatively from the global perspective, we still have a very lower kind of labor cost. And one simple idea is, for example, part of the Fiat operations when I was there between 1997 to 2003. In Belgium, at that point of time, the highest labor cost in roughly about 2003 was $38 per hour. And at that point of time in India, the average labor cost was about $2 per hour. That's the kind of huge difference which is giving us a competitive advantage. We are also looking at a very aggressive, kind of initiatives by various state governments in the last 1 decade, offering attractive land and, kind of infrastructure and various subsidies so that they can attract, kind of technology and industrial investments into different states in the country. And also, perhaps when we look at the kind of crisis which happened for post-COVID, for kind of technical kind of imports coming in for our car industry, and we were looking at this big kind of crisis, that how we are going to really get into a kind of self-sufficiency on certain highly technical components coming in or required by the car industry. That is where perhaps we are looking at global MNCs now either getting into joint ventures or getting into their own investments into India. Specifically, Gujarat has been very aggressive on this front. Next one, please. The overall kind of India vision with the present government led by the Honorable Prime Minister, I think Atmanirbhar Bharat has been very aggressively talked about, which translates to a self-reliant India. Basically, a phrase initiated by Prime Minister himself and his government, and popularized in relation to the country's economic development plans, and to a great extent, big investments on infrastructure. The phrase is an umbrella concept for the Modi government's plan for India to play a larger role in the world economy. And that is what perhaps is most of the global economies are now realizing. And perhaps this is becoming possible for the kind of efficiency uh, which is seen in our context, maybe the competitive edge and maybe the resilience. And COVID was one very big example, the way I think our country handled the COVID pandemic compared to other global economies. I think there was a very excellent example for resilience being part of our culture, part of our upbringing, part of our country's big strength, handling a crisis like COVID pandemic. Also, perhaps when we are looking at Viksit Bharat 2047, I think all the corporates are quite well aligned now for this initiative, which is aimed at realizing maybe India's aspirations of becoming a developed economy, a developed nation by 2047. This is the kind of larger context for our country to have this, real advantage of a kind of a preferred shop floor for global multinational with the tech and talent advantages. Next one, please. Now, one thing which perhaps at the Maruti's board level was discussed post-COVID in a very aggressive way, because there was this major shift from the erstwhile, VUCA world environment to Bani, defining how exactly you are going to face the kind of turbulence which is likely to be there. When we talk of, VUCA world, which was very famous for last roughly about 10, 15 years, defining various challenges. But perhaps when we shift to Bani, and which was very well, explained by the creator of this new concept, is brittle is what they explain is easy to shatter, subjected to a total and sudden failure. The second part, anxiousness, is that whatever choice we make in the corporate world, perhaps might be the wrong one. That is the anxiety. And when we look at the non-linear part, I think disconnection between cause and effect in time, proportion, perception which is becoming clear in terms of the complexities which the corporate world is facing. And incomprehensible is extremely difficult, if not impossible to understand. Attempts to find the right answer no longer make any sense. So right now, perhaps instead of people looking at a 7-year business plan, they have fallen down to maybe a 3-year business plan because of the kind of uncertainties and volatility which is existing. When we look at this kind of post-COVID situation, next slide, please. We are looking at the emerging new normal, and perhaps the kind of next practices which are required to handle this emerging new normal. During and post-COVID, industry, trade, and business face new challenges. For us at Maruti Suzuki in April 2020 was the only month in our history of roughly about 40 years that we did not make any cars and we did not sell any cars. Zero production and zero sales. We have never experienced this kind of a situation any month, but perhaps last 40 years. But perhaps that's the kind of new kind of situation which was emerging. Maybe therefore leadership capability was more on decoding a crisis, handling adversity, complexity, managing change, and looking at uncomfort zone of flexibility. Flexibility is always creating a kind of discomfort because we would like to remain, watertight in our comfortable environment, familiar environment. Also, perhaps a new trend emerged is that companies must learn to challenge the status quo. Whatever is happening for the past 5 years, 7 years may not work. And therefore, challenging the status quo with a challenging spirit to adapt, adopt, and change part of the new normal. This was again creating a lot of discomfort. And at that point of time, I think if you all remember, we suddenly learned for this virtual meeting mode to be the only way to connect with our people and with our business, with our dealers, with our suppliers. Virtual meeting mode, which at that point of time, March 2020, before that, we were never so reliant or so convinced about virtual meetings, but life changed in COVID. Digital potential, therefore, with new business processes, agility, speed, flexibility became the norm of the day. Startup companies with e-commerce platforms, with social media kind of driven reach, maybe everybody was able to handle it on their smartphone. Another big development. And therefore, need for revisiting the business strategy and framework. And at that point of time, we also looked at how we are going to handle the HR strategy, how we are going to handle engagement, well-being, not only physical well-being, but also mental well-being of our people. So a lot of change happened at that point of time. But I think one very significant thing which we are still grappling in corporates is whether work from home is the best or work from office is the best or work from anywhere is the best, or whether a hybrid model is going to work. So it is still a kind of a puzzle, which some kind of business leaders like Elon Musk and many others have been talking about work from office, necessarily, compulsory. But there are many corporates, many sectors which are still working on a work from home concept. So there is a kind of a puzzle which is, but obviously one big learning was that we'll have to accept the new way of life. Next one, please. Interestingly, when we look at people, we are looking at three very, very critical dimensions post-COVID. One is the change of nature of work. So because of the business environment, Bani, VUCA, and this digital disruptions coming into play, a lot of globalization and reverse globalization taking place. So nature of work has changed big way. And a lot of upskilling and continuous kind of capability building is coming into play because of this nature of work. And it is being forecasted that future of work will be one very big challenge for people, for HR, for corporates when we look at next 1 decade, 10 years. Change of workplace. Perhaps when we look at the work environment, as I said, before COVID, a lot of changes have happened in terms of open offices. Like Maruti Suzuki, we don't have the cabin culture at all. But now many companies, including European and US companies, are looking at this open office kind of concept. Very highly technology-driven kind of workplace. We are also looking at maybe this work from home concept post-COVID coming into big way. We are looking at diversity picking up big way. So therefore, POSH and maybe whistleblower mechanism coming into play. And we are also looking at change in the workforce. A lot of young people, the kind of alpha generation, which we are now talking of, generation X, Y, Z, maybe we are talking of alpha now. So in Maruti, for example, almost 4 generations of people, part of the 40,000 people, they work together. And when we look at older people, they have different expectations. When we look at the most young people, they have different expectations. And I'll just give you one simple example. When we are looking at the people at senior level with higher on age, their expectation is post-retirement medical insurance. But when we look at people at the youngest category in Maruti, they are looking at a variable pay, like a quarterly kind of a bonus, so that they can get cash every 3 months. That's kind of, they don't understand what is this medical insurance because they are very young. That's the big difference between the HR strategy which we are going to handle for coexistence of multi-generation of workforce. Adaptability, therefore, one learning is that perhaps adaptability, flexibility will be the key to success. Next one. Globally, perhaps we have also observed 4 major trends which are taking place. Next one, please. And these global mega trends will be definitely impacting the corporate life, the business performance. And therefore, perhaps it is important, I think, for us to understand, decode what are these 4 major global trends. This was first time discussed in our board kind of review at Maruti in 2022. One is that purpose over process is going to be the kind of shift. So purpose-driven leadership will be more important than ever. And as leaders aim to create agile and adaptable cultures, a common goal or a shared purpose becomes the unifier. So that will be driving people, their motivation, their direction, their involvement, intrinsic motivation. And therefore, successful leaders must relinquish control of process rather than empowering their people and relying on a shared purpose. So that's the shift which is happening. So we are looking at more decentralized, empowered teams with a shared purpose, common goal, becoming maybe the trend of the day. Second one, which is talked about a lot in India also, and I think government has done extremely well on this one front, reskilling for the future. So the National Skills Corporation, for example, has been mighty successful for the last roughly about 10 years, doing some outstanding work. The concept of continuous learning has never been more relevant. So both employees and job seekers, the ones who are going to get into industry, are being encouraged to sharpen their skills. Now, reskilling not just once, but over and over again, should be a top priority for both individuals and organizations. And therefore, talent will become less important. Learning capacity, capability to learn new skills will become more relevant as we go along. The third one, the next slide, please, is a concept where we are talking of, kind of a continual state of transformation. So don't stand still. All leading corporates are and will continue to be in a continual transformation. So because of the kind of volatile kind of environment which we are facing globally, perhaps the kind of changes which are coming in through the digital kind of potential. So jobs and structures will be continuously honed to promote agility and scalability at every level. And with every strategic change, leaders must reassess and realign to drive execution. That's the kind of shift which is going to be the third major trend, global trend. And fourth, which is very close to my thinking, which I have been talking about for some time now, is the capability in companies to selectively delete the past. So this, very difficult to let go, create new storage space, flexibility, new ideas, maybe out of box. So that kind of shift, maybe new space for potential development or growth, maybe the opportunity share. That's the kind of shift. This is the fourth trend. Also, perhaps there is a lot of discussion in the last roughly about 3 years, and various kinds of deliberations in conferences. Is future of work and workplaces. What is going to happen, especially with the impact of artificial intelligence, machine learning, bots, automation. Lot of people in the last 2 years, when I have been addressing conferences, have been asking whether artificial intelligence will replace, generative AI will replace HR. That's the kind of curiosity and anxiety with which people have been seeing these kind of digital disruptions. Consequent focus will be therefore on, when we look at AI coming into play, or when we look at other kind of, machine learning, bots, automation coming into play, various processes. I think more important will be capability to reskill, maybe upskill. So that will be a continuous challenge as we see. And therefore, I said learning capacity will be more critical than talent. We are looking at maybe this puzzle of work from home, work from office, work from anywhere, maybe possibly a hybrid model customized to a business sector. I think that will be the best approach. At Maruti Suzuki at the moment, we are looking at 85% people working from office and 15% flexibility for business heads, business leaders to decide if they would like to give kind of flexibility to their people to work from home. Also, maybe flexi working hours and maybe workplace, as I said, can multiply in future. So that kind of flexibility we should be prepared with. When we are looking at the talent landscape, we are also looking at this big shift. Next slide, please. Is the kind of next one, please. Just go ahead with one more slide, please. We are looking at this contours of the alternative talent landscape, and we are talking of, just go back, please, the previous slide. The previous one, please. Yes. So we are talking of this new development of the gig economy. And when we are talking of India as the preferred shop floor for a world with the tech and talent advantage, I think gig workers is another very major development in the tech area, and perhaps it is altering the talent landscape and the way people view work and perform work. And the digital, platform-based gig economy is witnessing a transition where full-time workers are turning themselves into freelancers. So a couple of years back in Detroit, we were looking at hiring some senior R&D talent from the American auto companies, and there one gentleman, a US guy, whom we finalized for the design and development role at Maruti Suzuki. When I was talking to him about the employment contract, he mentioned that he will be interested in a 2-year contract, not a long-term appointment. So that was a bit of a surprise for me. And when I could understand from his perspective, he wanted to help us do a design project for a couple of new models and then move on. That's the kind of shift we are saying, the share of gig workers in major economies, what we saw globally. India is also catching up on that trend. So perhaps when we look at their aspirations, we are looking at kind of a dexterity in profile by doing different roles. So they pick up, kind of multi-skills. That's the kind of concept is emerging. And also next slide, you just went ahead with that one. We are looking at big potential of a positive diversity trend. So Indian corporates are promoting diversity in a big way. And unlike earlier thinking that automobile companies, manufacturing companies will not be able to work with female talent, I think now diversity in a much bigger perspective, including people with special abilities and gender diversity, is all being part of the kind of HR policy framework. The next one, please.
Ladies socks.
Pardon? Did somebody have some question here? Anyway, so perhaps when we look at our own example at Maruti Suzuki, in the last roughly about 3 years on shop floors where we make cars, I think we have started looking at creating special lines where only female operators are working. So perhaps when we look at this big talent advantage of only operating with 50% male kind of candidates. Now, in the last 5 years, this global trend has started catching up in India a big way in corporates. And as I said about Maruti itself, Jimny line, for example, where Jimny Jeep is being manufactured, is now being handled by all female operators, supervisors, engineers. That's the kind of shift we are looking at maybe over the next few years in a very big way. Next one, please. All this while we are talking of the people, we are talking of skilling, we are talking of this Bani world, we are talking of the trends and kind of challenges. I think the role of human resources will become very critical because we are going to deal with talent, we are going to deal with technology, and we are going to deal with transformation. Simultaneously, these three factors will have to be looked at, perhaps when we look at overall kind of a macro HR strategy for companies. In case of Maruti, perhaps when we are looking at the current 40,000 people, being able to do about 2 million plus cars, 21 lakhs, 22 lakhs cars per year. When we are looking at future, perhaps I'll be talking about it, then this HR kind of strategy will become very critical. One is that perhaps very critical to define or rather redefine the talent strategy, how we are going to handle people, their capability building, their engagement, their retention. We are also looking at customized adoption of technology, digitization. Uh, Most companies are going through that process at this point of time, but digitization will have its own challenges also. In the Indian context, copying digitalization of what US is doing or Europe is doing, I think will not be the right strategy. So some customization will be required, which suits our country because we have got a kind of lots and lots of potential for uh, a kind of trained, skilled manpower to be available, whereas that is not the case in many other countries. And perhaps to a great extent, this is also a kind of strategy that if we are able to bring in the kind of customized adoption of technology and digitalization, our talent capability go and work globally for countries such as Japan and Germany, which were not very open and flexible to get people coming from different countries and working in their country. Now they have started opening in a big way. And both these countries are very specifically looking at Indian talent to be going and working in their countries because they are aging and they don't have that kind of young, skilled manpower. We are looking at speed, responsiveness, flexibility, and reach, obviously, with kind of tech and digital kind of era kicking in. We are also looking at a big shift is perhaps productivity, which conventionally used to be one index which was measured. Now I think the entire HR strategy perhaps will look at HR measurements and value add to business. So maybe when we look at manpower cost as a ratio to the sales turnover, when we look at the attrition kind of numbers, how you are going to retain maximum people, maybe in our case is fortunately a single digit, maybe 4 or 5%, but many companies are struggling with attrition of 18, 20% or even more in IT sector. So perhaps some such business indices will help measure the HR value add to business. And obviously looking at potential kind of digital changes coming in for transformation. Handling transformation will be more important in terms of dealing with the mindsets of people, flexibility, adaptability, maybe agility, learning capability, and maybe out of box new ideas, innovation. Next slide, please. Now, when we are looking at this real capability of the Indian talent, and maybe look at this technical capability as well as soft skills, I think we are looking at this 40-year-old story for Maruti. At that point of time, when I joined 2003, it was a major transition that Maruti Udyog Limited, originally the company, a public sector company, established in 1983, with 74% equity with the government of India and roughly about 26% technical kind of equity coming in from Suzuki, Japan. And then rest is history, I think, in terms of the kind of revolution which was brought in by this company. Next slide, please. When we look at this transition of Maruti Udyog Limited to Maruti Suzuki India Limited, I think in terms of a decision by the government to disinvest into Maruti, made this first possibility of Suzuki having the majority shares of 54%, and government came down to 10%. And then subsequently in 2006, government decided to disinvest even that 10%, and Suzuki Japan became the owner of this company. And at that point of time, this major shift when I joined 2003, there was a one-line board mandate that Mr. Siddiqui changed this company from a public sector company to a private sector company. And that too part of a Japanese multinational. Very easy to say, but very difficult to really bring that kind of a change. And it took me roughly about 5 years for changing this company into a private sector company. It largely, as I said, dealt with dealing with people, dealing with the mindset of people. And Mr. Bhargav, who's currently the chairman of the company, was at that point of time when the company started in the initial years, also became CMD, chairman and MD of Maruti Suzuki. So he is referred as the father of Indian auto industry. So he used to tell me, past experiences while helping me to bring this change of a public sector company to a private sector company. And he always said that you'll have to target dealing with the mindset of people. And he gave one example that when it was decided in the initial stages that we will not have cabins in Maruti Suzuki, maybe somewhere in 1987, 88, he says the biggest resistance came from senior people, not from anybody else, but senior people. They wanted to retain their cabins. And you will be surprised that when I joined Maruti as the head of human resources in 2003 September, I was just sitting on a 4x4 table in a big hall, surrounded by all my people. So no cabin, nothing. That's the kind of, so maybe I think one key learning which I thought will be important for us to know is that any company to succeed with this kind of a transformation, change, whether at that point of time or even now, I think leadership vision will be critical. The change, how it is driven, and I'll talk about it quickly in a few slides, how this transformation is arrived at. Maybe looked at the adaptability quotient, lot of training, and look at collaboration, working with different people for a common goal. Next slide, please. To quickly talk to you about 4 different phases of this journey for Maruti Suzuki last 40 years. When you look at phase 1, it was basically 1983. Suzuki Motor Corporation 24%, Government of India 76% equity. Situation market at that point of time was very simple. Dominance by our product. So basic focus was production operations and learning the Japanese work culture and Japanese work practices. That was the phase 1, 83. When we look at phase 2, which was roughly about 10 years later, 1992, Suzuki became 50%, Government of India became 50%. This company became a joint venture between Suzuki Japan and Government of India. At that point of time, some competition was emerging into car industry. And therefore, little focus shifted on defining new marketing strategies, customer orientation, and also because of the high production focus, industrial relations, managing the union became also a kind of a big challenge for Maruti. Phase 3 is the point where I joined the company, 2003. So government decided to disinvest. And as I said earlier, Suzuki got 54.2% in the process. And the change of Maruti from a public sector company to a private sector company. So focus, as I said earlier, was more on mindset of people, HR policies, processes. But at the same time, we also saw the external environment, competition was getting tough, and customer delight was coming into focus. So for this major change of public sector to private sector, I think big shift in the HR strategy. And we were looking at something like 2010 as the target to achieve, but we could achieve it in 5 years itself. Phase 4, perhaps 2010 onwards, target was to reach 2 million by 2020. We got delayed by a couple of years because of COVID. So a lot of globalization and maybe the VUCA business environment was driving the external business environment. So therefore, vision quotient of the top leadership, business strategy and innovation, maybe how we are going to handle the global kind of competition, because every global automotive company was here in India, and therefore a lot of focus on marketing and sales infrastructure, new product strategy, and obviously people strategy in terms of skilling, capability building, and where perhaps we look at this, talent and tech advantage was the key focus. And perhaps when we are looking at now, we can look at phase 5, maybe looking at 2030, and I'll talk about it a little later. Next slide, please. Can we go to the next slide, please? Dr. Atul, can we go to the next slide, please?
Dr. Atul? Just a second, sir. Just a second.
I have changed the slide, but I don't know why it is not showing here. Should I
Just go ahead.
reshare?
Yes, sir, you can quit this and reshare again.
I think you'll have to reshare because there seems to be just stuck, hanging. Okay, I think saving time. When we looked at this shift, I think major kind of subject which I wanted to talk is that any such change or transformation which we experienced 2003, I think depends on ownership of the top management. That is most important learning. And perhaps the top leadership should walk the talk, talking about this change, how we are going to really bring a kind of a very sharp competitive edge to remain number one in the auto industry. That is what we talked at Maruti. And also maybe a very high focus on communication. But perhaps when we look at the key principles for any such change management perspective, I think one is first principle which we could understand is clearly defining the need for change, why we should change. And at that point of time, perhaps we looked at that if for Maruti to stay competitive, we'll have to really be operating like any other global automobile manufacturing company like Hyundai or General Motors or Tata Motors or Mahindra. So that was a clearly defined need for change. Second is that all senior leadership business heads, they should involve fully and own this change rather than having a conflict or a difference of opinion. So that was the second principle. Third is creating a shared goal. And I think our shared goal was very simply that by 2010, we would like to continue to be number one automobile industry in India. That was the shared goal, so that everybody should benefit and everybody should, be doing well along with the company, uh, including part of profit sharing. And fourth principle, perhaps to a great extent, was listening leadership. A lot of focus on internal communications, the views expressed by people, the kind of challenges being faced by people. So a lot of listening leadership, and therefore communicating well with people, involving them in the change. And then maybe looking at the last principle that change should be gradual, should not be overnight, should not be shocking, should not upset people. And maybe also the simple fact that initially there will be discomfort. So short term pain maybe for long term gain. That's the kind of principle we looked at. Also, perhaps the culture perspective is very critical when we look at this, tech and talent advantage. One understanding perhaps is that the kind of eco environment we provide for people to exist, people to feel intrinsic motivation, to learn, to get skill, get multi skill and perform. I think work culture becomes extremely, extremely critical. Just go to the next few slides, please. we are looking at developing a positive work culture. Couple of slides ahead. I just covered all this already. You can move ahead. Yes, please. You are now with me. Yeah. That's perfectly fine. So we are looking at maybe the culture perspective, and perhaps when we look at involvement of our people, annual kaizens in Maruti Suzuki by people are roughly about 300,000 per year, 3 lakhs per year, and resulting in a saving of roughly 200 crores per year. That's the kind of culture perspective I'm talking of. And when we look at people involvement and ownership, that becomes critical for the capability for any company to really exceed performance expectations. We are looking in this big change from public sector to private sector, maybe from strong functional identities. I'm supply chain department, I'm marketing, I'm sales, I'm production, I'm HR. We shifted to the Maruti Suzuki team concept. Perhaps when we were looking at very bureaucratic policies and procedures, we shifted focus on speed, transparency, and process approach rather than individual focus. So some such perspective, very high focus on teamwork and team synergy, maybe looking at very high focus on empowerment, ownership. Somewhere perhaps we also looked at this shift to the Japanese management practices, and I'll talk about it in the next slide. So basic focus is very high people involvement, ownership, and maybe driving high performance. That's the kind of culture quickly I wanted to share, that when we talk of this tech and talent advantage, that reflects into what kind of people and what kind of culture we promote in the company. That is the big advantage which we have in India at the moment. Next one, please. Next slide, please. We are looking at Japanese work practices, which is directly bringing in this capability, which is now being adopted by many Indian corporates and multinational companies. This principle of 333, basically one big learning. One, every operator must know 3 jobs. Every operation must have 3 experts. And line associate must know his workstation, but also know his previous workstation and the next workstation. That is the principle of 333. And we are looking at Kaizen as a suggestion scheme. Zero inventory, we do not have any stores in the company. So we have this capability of our people to work on hours. So 4 times the suppliers will supply material to Maruti and will directly go into the shop floor, directly get converted into cars. So every day, roughly at the moment, our capacity is between Gurgaon, Manesar, and Gujarat to produce roughly about 8,000 cars per day. When we are looking at cost down initiative, I think as a mindset, as a basic thinking, all the time improving something better than yesterday. So one example I wanted to quickly use is we decided a few years back, based on this learning from Suzuki Japan, our parent company, that let us reduce 1 gram weight of each part which goes into a car. So roughly 5,000 parts which go into a car. If you reduce 1 gram weight of each such part, it will save you 1 yen or 1 rupee. That was the basic drive. That was the basic project. And when we looked at that project, then initially people outside Maruti talked of, what are you working on saving 1 rupee or 1 yen? So when we looked at our kind of production, at that point of time, we were producing roughly about 16 lakh cars per year. So if you look at this 1 rupee saving with 5,000 parts, that means 1 car is saving 5,000 rupees. And 16 lakh cars are saving roughly about maybe 800 crores per year kind of stuff. That's the kind of strategy when we look at new ideas, when we look at something out of box is going to work. Also the concept of 3G, which is Genchi and Genbutsu and Genjitsu. We say that don't discuss things in the conference room. You go and visit the place of action. Go to the actual place, see the action, and take necessary action. Concept of 3G. Actually, the action side. So that's very big learning from Japan. Most of the times we try to solve the problems in a comfort of a conference room. Better to go to the Manesar plant or Gurgaon plant or Gujarat plant and see what is happening there and then decide what is to be done there. Next slide, please. Another concept which is a big learning from our parent company is the concept of job rotation and therefore developing the kind of talent capability. And that concept has become very popular in the Indian context now. This basic concept of job rotating people is part of developing somebody's career, maybe new exposure, versatility, new capability, applicable at all levels, managerial levels, shop floor, ITI, trained people, diploma engineers, graduate engineers, everywhere. And we use it to the best of our capability. So every year this opportunity will come for many people in Maruti to change their roles. Similarly, maybe in 2015, I also changed from HR to a business role. And that's the kind of development which really comes across. Next one, please. Any company which perhaps when we look at this disruption to co-creation, any company which is 30, 40 years old, it requires a change. It requires to selectively delete some of the past, creating the new curve. And therefore, we are also looking at last 3, 4 years, need to identify areas to de-learn, maybe delete, revisit the organization design, leadership development, work culture, people processes. A very big exercise is going on at this point of time. Maybe look at the business strategy. So a lot of digital is coming into play now for our marketing and sales strategies. You can perhaps maybe very shortly, you can see our cars without going to the dealership. Everything which you want to see in a car, you can see it on your laptop, iPad itself. And when we look at Nexa as the new latest dealership of Maruti, perhaps that is one big change in the business strategy. And maybe we are looking at transformation of new products, so now electric vehicles. Maybe very shortly, announcement will be there for launching the first EV of Maruti Suzuki. Next one, please. We are looking at this capability, which is selectively deleting the past. I think this is very important for us to be globally competitive. And when we look at our Balenos being, supplied to Suzuki Japan, the parent company, I think to a great extent, this journey of 40 years is in terms of selectively deleting the past, maybe changing from public sector to private sector, but even becoming private sector in 2003, 4, 5 years of effort. Now we are changing things so that we can become more competitive in terms of our global presence. We are looking at, when we talk of change, as I said earlier, change of mindset. And when we are looking at inability to move on from the familiar and comfortable, I think that is the biggest challenge. So we must endure some, new discomfort, maybe some short-term pain when we are looking at this big organization transformation, and also maybe some de-learning. I had this very big privilege of meeting, the next slide, please, uh, late Dr. Abdul Kalam, the President of India, and he visited, when he was the President of India, I visited Maruti at that point of time. And I just wanted to share one learning is that he spent maximum time with our engineering talent, design engineers, 21, 22, 23-year-old people in Maruti. Maximum time. Less time with the top management. But whatever time he spent with the young engineers, I think he was inspiring them for innovation, for out-of-box thinking, for flexibility, for taking experimentation, taking risk in the design of products. But the top management, he talked of can we replace diesel and petrol with an alternative fuel? Can Maruti lead that research? That's the kind of inspiration, perhaps meeting some such kind of top leaders. And fortunately, when Mr. Modi was the Chief Minister of Gujarat and we decided to invest in Gujarat, next slide, please. We had this great opportunity to interact with him, look at his thinking, look at his vision. And he was very, very excited that Maruti is investing into Gujarat. And I think it was a very memorable kind of few months we spent together in different meetings, and we could see his, real vision in terms of converting Gujarat into a state with great kind of infrastructure and attraction for multinationals to invest in. So some of those learnings, when we look at this tech and talent advantage, I think somewhere come from the vision of such, top dignitaries like Honorable Prime Minister and the late President Kalam. Next one, please. When I talk of the future, and when we are looking at a company like Maruti Suzuki, we are looking at 2030 to reach 4 million kind of production capacity and sales. So what we have achieved 2 million in 40 years, we are going to achieve doubling that in the next 5-6 years. That's the kind of speed, that's the kind of ambition, vision which we are going to talk about. 4 million, 3 million we will do for domestic market and 1 million for export market. We are looking at 50% market share, and we are looking at leadership in the SUV segment. But one learning which Suzuki Japan has been talking about is not the strongest of the species that survive, nor the most intelligent. It is the one that is most adaptable to change. So that's the quote from Charles Darwin, but I think very critical for the corporates, for professionals to absorb changes, adapt to changes, and don't be enchained by past practice. That's the key message. I think perhaps when we are going to look at globally a kind of tech and talent advantage. When we look at next slide and we look at the subject itself more specifically, I think the country's reputation as a premier outsourcing destination is well deserved. And a recent survey perhaps revealed that a staggering 80% of outsourcing firms in the US and Europe chose India as their preferred partner. Very big, I think, credibility. And this preference stems from India's ability to provide a highly skilled and cost-effective workforce, as I said, relatively lower labor cost. And one of the key themes of 2022 was talent, or more precisely, the lack of it. Most countries facing that challenge. I said Japan and Germany, but there are many countries which are aging and facing this big issue. The challenge for many companies that rely on technology is that they can't find enough of the right talent in their home markets. And one simple example is EV engineers, electric vehicle engineers in Japan, just not there. So Japan, Suzuki Japan, our parent company, 2 years back talked about why don't Maruti does something at Bangalore, at Pune, at Hyderabad, Chennai, Delhi NCR to develop these young talents into EV engineers. Global demand for the future. And perhaps they were looking at that such young people can work 2-3 years in Suzuki Japan. The kind of exposure globally, which will be great. And maybe I think one of the kind of this thing which we are looking at is that the kind of aging which is being experienced, for example, in Japan, is a big challenge. I think aging population above 70 is becoming larger and larger, and younger people for the kind of industry and manufacturing sector going lower and lower. Big problem, and therefore they are opening borders from Philippines, from India, from one or two other countries where they are inviting people to come and work there. Next one, please. One, kind of very important this thing coming from Conferry, HR advisor, that by 2030 there will be a human talent shortage of more than 85 million people. Roughly the population of maybe Germany itself. And without action, that translates into about 8.5 trillion in unrealized annual revenue by 2030. Now, this is huge kind of forecast. Maybe 80% accurate or 75% accurate, but it indicates a trend to me is that perhaps there will be an opportunity for our, highly skilled young manpower. Big opportunity. India, home to the world's single largest pool of workers, may hold the key. And perhaps it has a kind of tech talent surplus. Many global companies expanding their Indian headcount, some doubling numbers in last 2 years, especially post-COVID. And perhaps when we look at Bangalore, when we look at Chennai, when we look at Delhi NCR, I think all engineering hubs are coming in for global auto companies to be operating from the Indian shores and with Indian talent driving this kind of engineering new product development process for them. And maybe I think when we are looking at this big kind of development coming into our favor, I think to a great extent there's a big scale and obviously talent, but I think a kind of cultural propensity to adapt to a new situation. Indian talent is on top. This cultural propensity to adapt to the new changes. Our people who have been working in Japan have already proven that point from my personal experience perspective. They have learned the language. They have started living the way the Japanese live, that Japanese work, that punctuality, discipline, everything. Next one, please. We are also looking at maybe lower labor cost and the lack of significant language barrier. English is very easy for us to handle. May have initiated the Indian expansion, but today the sheer volume of skilled data science, advanced analytics, the cloud computing, and AI specialists graduating each year is a big magnet to attract these global economies to invest into Indian talent. And maybe when we are looking at 500,000 new engineers coming into the labor market every year, maybe if you take a broader view and include graduates with technical skills, it will be 800,000. So that's the kind of huge potential we are talking about. And rich stream of digital natives makes India the world's largest provider of technical talent, not just today, but maybe for decades to come. So naturally, I think most companies will be looking at globally India as a destination. When we look at maybe the kind of government support for startups, next slide, please. I think it is, as I said initially, the vision of the Honorable Prime Minister and government and perhaps the support for startups. When we are looking at this booming digital economy in the Indian context, we are looking at Paytm, we are looking at RuPay, we are looking at so many things happening all around, and some unicorns coming in, playing a huge role. I think that is creating another very big potential. According to McKinsey's report, the digital economy has the potential to unlock 60 to 65 million new jobs by 2025. Huge by any standard, and many of which will require strong digital skills. This rapid growth signifies a surge in demand for professionals adept at working within the digital landscape. I think our capability for upskilling, capability, and the culture propensity for adapting is going in our favor, big way. And when we look at the industrial training institutes, next slide, please, we are looking at a big shift in terms of privatization. And Maruti itself is currently managing roughly about 30 industrial training institutes and 3 instructor faculty training institutes in the country. And that kind of people who are almost ready to be hired by industry day one, they can start running, and that's kind of focus on technical skills. But I remember when I started this initiative in 2005 with first few ITIs from Haryana government, Mr. Bhargav was requesting again and again that Mr. Siddiqui look at soft skills, look at training them into Japanese work culture and work practices, soft skills, that focus, communication, behavior, discipline. And I think it has gone a big way in preparing our kind of 30 ITIs where we are bringing in people. They are getting absorbed in other OEMs with our dealerships, with our suppliers, and therefore employability also is a good outcome. So that is another big potential for this tech and talent advantage when we are looking at privatization of ITIs and the kind of sheer number. And maybe we are also looking at maybe next slide, please. We are looking at initiative by our company in terms of Japan India Institute for Manufacturing gyms. Started the first one in Gujarat and the second one in Haryana. And we are looking at offering some more. Gym basically has accreditation from METI, which is Ministry of Economy, Trade and Industries, Japan. and National Council of Vocational Training India. They are offering two certificates to students, one from NCVT India and another from JIM on Japanese manufacturing practices and processes. So course designed by METI and AOTF, which is a Japanese company, overseas training kind of support to companies from Japan which are investing into India, is another very professional kind of agency. And maybe we are looking at least few more gyms to be bringing in this capability, uh, uh, really high class manufacturing talent at the shop floor. This is a small contribution from the company itself. Last slide, maybe the next one, and then perhaps I'll be open for your questions. When we are looking at the future of tech in India, I think very important for us to look at this continued success as the starting point. And with large talent pool, I think government support and robust digital economy, I think we are well positioned to become a global center for innovation. And based out of this, real tech and talent advantage. Maybe as new technologies like quantum computing, blockchain, AR, VR, gain traction, more criticality into the kind of business processes, products. India's tech workforce is well equipped to adapt and thrive this ever evolving landscape. I think we are in a very, very healthy potential space at this point of time. If we continue to handle, further capability building and this focus, kind of robust infrastructure supported from the government, I think we are going to do extremely well. So that's all I wanted to share, and then we will be looking at questions, anything which you people may like to raise.
Any questions from any participants? Any question? Well, participants? Well, sir, I thank you for sparing your such a valuable time for our participants, and I hope that your insightfuls will be very helpful for them in the near future.
Thank you, Dr. Kohli. I think it was a privilege, and maybe wishing all of you the very best. All this initiative, I hope, can create good careers for them. And when they do well in their careers, I'm sure they'll be looking at buying cars, some decision. So request is please consider buying only Maruti cars. Wish you all the very best. God bless.
Thank you. Thank you so much, sir. Thank you.
Thank you.